विवेक सर। विवेक सर,
हाँ हाँ हेलो.
आई थिंक वी शुड स्टार्ट.
ओके. So welcome all of you to this session on behalf of IPS College of Technology and Management. I welcome you all for this session. Today we have with us Dr. Ella Maran Jayamani. Welcome doctor. I would like to introduce Dr. Jayamani. He is currently Associate Dean and Associate Professor, External Engagement and Impact. He joined Swinburne University of Technology, Sarva campus in 2007 and a creative educator for over 23 years, promoting sustainable materials research and development. He has PhD in mechanical engineering, specializing in material and processes with expertise in learning and teaching, research and scholarship, and leadership and service. He is well versed in training and mentoring students, research scholars, and educators. He has completed his graduate certificate in learning and teaching higher education at the Swinburne University of Technology, Melbourne, Australia. He is a member of Institution of Mechanical Engineers, Chartered Engineers, and MIMECHE UK, International Professional Engineering UK. His main research areas include polymer matrix, composite materials, energy, and environmental sustainability, and learning and teaching. His research interests are energy and environmental sustainability, thermofluid system, polymer matrix, composites, and learning and teaching. So, this is a brief introduction to Dr. Jaimani. I would request our distinguished guest speaker to start with the session. Thank you.
Good afternoon, everyone. Can you hear me?
Yes, sir. Voice is clear.
Yes. Thanks for IPS College of Technology and Management for inviting me for this special talk under this program. Welcome, everyone. I'm Dr. Ilamaran Jayamani. Few minutes, sorry. Close it. Okay. Sorry for the interruption. Good afternoon, everyone. I'm Dr. Ilamaran Jayamani, Associate Professor of Mechanical Engineering at Swinburne University of Technology, Sarawak campus, coaching Sarawak, Malaysia. Today, I would like to present the topic on dielectric materials and their past, present, and then future. These are my presentation outline. It consists of introduction, dielectric materials, past dielectric materials, problems in dielectric materials, what is sustainability, sustainable development goals, present dielectric materials, dielectric composites, sustainable materials, present bio-based composites for dielectric applications, what is sustainable manufacturing, value chain, and then conclusion. We all know that materials, whenever we can talk about materials, are used for making something physical object. When we can say materials, they are classified under metals, polymers, ceramics, and then composites. We all know that. But actually, what exactly? Whenever there is a technology development, there is a new product in the market, it means there is a new material developed by the material scientists. That's what said. It is always new material that open the door to new technologies. Whatever may be in the field. The field may be like civil engineering, chemical engineering, construction, nuclear, aeronautical, agricultural, mechanical, biomedical, or electrical. In simple term, whenever there is a new material, there is a new technology. That's what our technology grows up these days. Material science engineering influences our lives each time we buy or use new device, machines, or structures. We know that each day, these days, there's a new technology due to new materials. For example, we know the size of TVs before and now. We know what is the mobile phone size before and now. We know what is the various, even thumb drive, you can take example, pen drive, what is the size before and now, external hard disk. So how this is possible? Lot of semiconductor devices. All these possibilities are due to there is a new materials. So material may be chosen for its strength. Some application strength is important. Some applications electrical properties are important. Some applications resistance to heat and corrosion is an important, or a host of other reasons. But they all relate to properties. So whenever we need to have a materials, there is a new technology that grows based upon it. For example, you can see at the right side, these are the latest materials, self-healing materials, transparent solar panels, bioplastics and biocomposites, mycelium, nanocellulose, advanced ceramics, liquid metal alloys, quantum dots, graphene, gallium nitride, and then the thing is titanium. So these are the latest materials these days available in the market. Due to this lot of technology, we know what is materials generally, metals, polymers, ceramics, and composites. What exactly dielectric materials? Some of us know that what is dielectric materials because these materials exist everywhere. Whenever we can have a semiconductor device or electronic device or electrical component, we have this material. We are going to talk about more on what are the present, what are the past, and what are the future materials to be for dielectric application. You can look at this picture over here. This is the insulator or dielectric material on the right side. You can see at the bottom of the figure, whenever you can just give the power supply, there is a electrical energy stored on this material. Those materials are called dielectric materials. That's what you can look at the definition. A dielectric material is a poor conductor of electricity, but an efficient supporter of electrostatic field. It can store electric charges. So in simple term, we have to understand such a way that dielectric materials are able to store electric charge whenever there is an electric supply is there. An important consideration for dielectric material is its ability to support an electrostatic field while dissipating minimal energy in the form of heat. During the process, some material can store electric energy. At the same time, they give a lot of heat as the form of energy. But we need to have a material in such a way that it can have more electric charge at the same time, minimal amount of energy release due to heat. That is important these days. Okay, look at this last line. This dissipated heat or energy loss is known as dielectric loss. Lower the dielectric loss, the more effective the substance is as a dielectric material. What we have to understand means dielectric material means it must support lot of electrostatic field. It can store electric charge. At the same time, there is a less amount of loss in the form of heat. That is a good dielectric material. I think these pictures will explain you how these materials are used. For example, you can see at the center of the picture here, we got metal foil. In between, you get the green color one. The green plate is a dielectric material, insulator or poor conductor. Whenever there is a charge applied on it, you can see positive side and positive terminal, negative on the negative terminal. So the distance between metal foil, that gap can store lot of electric charges. So based upon the material, we can able to have more amount of storage, less amount of energy loss. Based upon, we are going to discuss what are the past materials, what are the present materials, what are going to be the future materials for dielectric application. Properties of dielectric materials. Of course, each material got properties. For example, metal, what are the properties of metal? We can say strength, hardness, toughness, malleability, machinability. Like that, we have a lot of definition, properties. Similarly, properties of dielectric material. The first one is electric susceptibility. How easily the electric material can polarize when subjected to an electric field. Okay, look at this point. How easily a dielectric material can be polarized when subjected to an electric field. So the polarization is an important term. What is polarization? You can say dielectric polarization is the amount of electric energy stored in the electric field when voltage is applied to it. It's an important point. The amount of electrical energy stored in the electric field when the voltage is applied. So polarization depends on what type of material. So depends upon the material can able to store a lot of electric charge when the electric field is applied or voltage is applied on it. And then what is electric dipole moment? The extent to which the negative and positive charges are separated within the system refers to electric dipole moment. The extent means just now we saw this is the extent. You can look at this picture here. The extent to which the positive and negative, the distance between metal foils, the extent to which the positive and negative poles end, that is electric dipole moment. So in simple term, we can say the amount of electric energy stored in the material during the electric field. That is properties of dielectric material. Apart from this, the common properties like thermal properties, glass transition temperature, decomposition temperature, electrical properties, dielectric constant, loss tangent, chemical properties, moisture absorption, methylene chloride resistance, mechanical properties, peel strength, and then fluctual strength. So we need to focus more on material, especially dielectric material, and then what is the amount of polarization. We have different types of polarization mechanism. The first one is electronic polarization. This is before electric field, this is after electric field. How the material behave. For an example, during electronic polarization, materials before electric field like this, after it goes like this, positive and then negative separates. Similarly, atomic and ionic polarization. Orientation or dipolar polarization, interfacial polarization. Because we know that some materials are homogeneous, some materials are heterogeneous. For example, you can take metals. Metals are homogeneous, copper, aluminum, magnesium, titanium, like that. You can take example, composite materials. It's a heterogeneous. Two particles inside. They are physically different and chemically different, but they combine together make a different properties. We got different types of composites like polymer matrix composites, metal matrix composites, and then ceramic matrix composites. These are called heterogeneous material. So the polarization depends upon whether the material is homogeneous or heterogeneous. Factors affecting dielectric properties: effect of frequency, effect of moisture, effect of temperature, and then presence of impurities. Because we know all that metals got some amount of impurities, either homogeneous or heterogeneous. So these are the factors affecting dielectric properties: effect of frequency, effect of moisture, effect of temperature, and then presence of impurities. One application where we can use these dielectric materials. We can look at these hybrid electric vehicles, because currently the electric vehicles are booming up. Hybrid electric vehicles, aircraft, military, consumer electronics like our TV, our washing machine. You can take our mobile, you can take our laptop, iPad, tablet, or consumer electronics. They have got dielectric materials to store electric energy. And then power grid, microelectronics, medical devices, and lasers. These are the applications where these dielectric materials are used in this day-to-day application. Functions of capacitor, because we all heard about the term capacitor, resistance, capacitance, inductance. What is capacitor? Can look at this point. Common use of capacitor is energy storage, power conditioning, electronic noise filtering, remote sensing, and signal coupling and decoupling. These are the functions of capacitor. So Capacitors are an important and versatile function to varied applications. They are used in wide range of industries. So capacitors are used in various parts of a machine or device or appliances. What is the function? First, the basic function is capacitor is to store energy. That is, all the capacitor consists of dielectric material. That's what we want to understand. Capacitors are able to store energy. How is it possible? Consists of some kind of dielectric material. So, capacitors are used in electronic circuits as a low pass, high pass, and band filters. As a term filter is a circuit that allows current and voltage of a specified frequency and waveform to pass through. So capacitors are used in electronic circuits also as a filter. So capacitors can charge and discharge because of the structure. It means capacitors can store energy whenever that is not necessary. It can release the energy whenever it is needed. So capacitors can charge and discharge because of the structure. Another function is maintaining the voltage at the same level. We know the term stabilizer. Actually, the stabilizer is a kind of capacitor. Maintaining the voltage at the same level, capacitors are also used to maintain the voltage at a certain level, same level or certain level. And then removing noise. For a lot of electronic appliances, to remove the noise, to filter the noise, we are using capacitors. So the capacitors are built using dielectric materials. That's what we have to generally understand, that capacitor consists of dielectric materials. You can look at the picture over here, type of capacitors: paper, polystyrene, bipolar, electronic, polycarbonate, polyester, mylar, silica, ceramic. We have different varieties of capacitors. Some capacitors are mostly made of ceramic, some made of polymer, some made of composite materials as well. Methods of dielectric permittivity measurement. How to measure dielectric constant? There are various methods that are available. The first one is parallel plate method, transition reflection method, open-ended probe method, free space method, resonant technique, microstrip patch antenna covered with the material under test. So these are the various methods available to measure the dielectric constant of various materials. They got pros and cons. You can look at this tabular column. Comparison of permittivity measurements methods. Here we got various methods: dielectric permittivity measurement, magnetic, the features. These are various methods. These are features. For example, if I want to measure which method is accurate, you can look at this. Parallel plate method is very accurate. This is a medium good, medium good, medium good, very good, and then medium good. Say I want to know what is the frequency range to measure the dielectric. It's average, very good, average, very good, average. So we can compare by using this method. In my research, two of my PhD students working under this topic, I will show you later on their publication as well as what they did. They are working based on parallel plate method. In Swinburne University of Technology, Sarawak campus, Malaysia, we got this parallel plate method to measure the dielectric properties of various materials. Later on, I will show you some samples. So I hope you got an idea now what is dielectric materials. Now, what are the classification of dielectric materials? Dielectric materials are majorly classified into two categories: linear dielectric materials and then non-linear dielectric materials. What exactly linear? We all know that what is the linear? It's corresponded, related to something. Regardless of the strength of the electric field applied, linear dielectric metals retain constant permittivity or dielectric constant. Examples of linear dielectric metals like glass, paper, certain plastics, and then they are used in various applications like transmission lines, capacitors, and other parts where steady, predictable reaction to electric field is necessary. So what we have to understand, there are two classes of dielectric materials, linear and then non-linear. Linear means it's based upon electric field. That's what the definition says. Regardless of the strength of the electric field applied, the linear dielectric materials retain constant permittivity or dielectric constant. What is non-linear? The permittivity of non-linear. Permittivity is nothing but dielectric constant. Actually, the term permittivity is other name called dielectric constant. The dielectric constant of nonlinear dielectric materials varies as the electric field changes. So that is called nonlinear. Example, barium titanate is one type of nonlinear dielectric materials. There is a nonlinear connection between polarization and then electric field strength. This barium titanate is used in various devices like actuators, sensors, as well as capacitors. And other types of nonlinear dielectric materials, silicon carbide. So what we have to understand here, both linear type of dielectric materials as well as non-linear type of dielectric materials used in various industries. Based upon application, both are applicable in electrical and electronic industry. At the same time, dielectric materials are available in the three phases: solid, liquid, as well as gas. We all thinking that dielectric materials means only solid. No. Dielectric materials are classified as solid, liquid, or gas. When we can talk about solid, rigid, and then flexible. For example, rigid solid like ceramic, plastic, glass, mica. These are rigid solid material for dielectric application. Flexible like polyethylene, polyamide, PDS. What about a liquid? Silicon fluid, synthetic esters, and then deionized water. It acts as a dielectric material. Gases also dielectric materials: dry air, vacuum, nitrogen, and then helium. So the dielectric materials are classified into linear and then non-linear. These materials may be solid, liquid, or gas. Mostly we are going to talk about what is the solid rigid material, ceramics, because the solid rigid materials are used in various semiconductor application, electronic devices. So our focus mainly on what is this rigid solid dielectric materials, what is ceramic, what is plastic, what is glass, what is mica. Classification of dielectric materials, just now we got linear and non-linear. Again, linear dielectric can be classified further into polar and then non-polar. Linear again classified into polar and then non-polar. What is polar? Polar materials have permanent dipole moments and undergo both electronic and ionic polarization. The meaning will be the polar dielectric materials undergoes electronic and ionic polarization. On the other side, non-polar materials do not exhibit permanent dipole moments due to symmetrical charge distribution, but can still be polarized by the external electric field. You can look at the example, you know that. Materials such as oil, wood, water, and are polar because their molecules align, can store, but very good conductors. On the other hand, non-polar materials such as concrete, ceramic contain non-aligned molecules which do not create an electric field unlike polar molecules. So we got linear, we got two categories again, polar and then non-polar. Most of the cases we are going to discuss more on both polar as well as non-polar linear dielectric materials. Classification of dielectric material. The first is ceramic. Ceramic is one of the oldest dielectric material, the past material we can say. The past material is ceramic. Ceramics have many desired properties including high stiffness, hardness, and abrasion resistance. Advanced ceramics are used in electrical industry due to their stability in extreme weather and high electrical resistivity. Examples of advanced ceramics include aluminum oxide, zirconium oxide, carbides, nitrides, silicates, and borides. These materials are called advanced ceramics. They are used in lot of industries as a dielectric material. Single crystal mineral silicates and silate tubes are used in capacitors for their high charge storage and low permittivity. Titanium oxide is used in capacitor due to high permittivity values, that is high thermal dielectric constant values. So ceramic is one of the oldest past dielectric material. Examples include aluminum oxide, zirconium oxide, carbides, nitrides, silicates, and then borides. What is glass? Glass is also one type of dielectric materials. Glasses are amorphous ceramic compounds made from silicon and then lime-based compounds. So it's an amorphous ceramic compound. There are two main faculties, that is families of glass. One is soda lime glasses and silicate glasses. So glass is also one of the important dielectric material. Soda lime glass and silicate glass. Pure silicate and borate glasses have dielectric constant between 3.2 to 3.8. This below 4.2 are called as low K dielectric materials. The meaning will be low thermal dielectric constant value materials, less than 4.2. So the silicate and borate classes are low dielectric constant materials at frequency 1 megahertz frequency. Additions or dopants can increase the dielectric constants of ceramics above 4.2. Sometimes we need to add some foreign elements, some other elements, fillers or plasticizers, so that can increase the dielectric constant. For example, the pure silicate borate glasses dielectric value is 3.2 to 3.8. You can add some kind of foreign elements on it. We can able to get until up to 4.2. So dopants can increase dielectric constant value. Apart from this, we have various glasses as a dielectric materials. Example, glass ceramics. The permittive values like lead borosilicate 7, magnesium aluminosilicate 5, calcium aluminosilicate 6, lithium silicate glass 6.5. You can see here, these are various glass ceramics and their permittivity. So we can able to increase the dielectric constant value. As I said before, whenever you can choose as a dielectric material, two things are important. One is dielectric constant. We must have high dielectric constant material. At the same time, low loss. That is important. Loss must be very, very less. So that is a good dielectric material. Glass ceramics also have high thermal expansion coefficients and can be used in high performance packing and pin grid array application. You can see electronic packing also we can use various dielectric materials, especially glass ceramics. Borosilicate glass and silica, these also the past dielectric materials, or we can say still they are used in the market, but considered to be the old one. Borosilicate glass and silica. Borosilicate glass is an amorphous material with a dielectric constant of 3.9 to 4.2. It is made with a pure silica and it's produced at a temperature of around 950 degrees centigrade. This is a very important point. Ceramics, we know that got higher melting point. Whenever we want to process ceramic as a material, it needs high temperature. You can see here 950 degrees centigrade. That's what I'm going to correlate with the climate changes as well. So to process ceramics, we need high temperature. How is it possible? We need to have either furnace, either electric furnace or coal-based furnace. Both gives a lot of CO2 emission that causes global warming and then other climate change issues. So ceramic, that's what considered to be not a sustainable material for dielectric these days. Why? These days, scientists are looking for a different material means it is not sustainable. It needs 950 degrees centigrade to melt the material. So silica has a permittivity of 4 and it has standard limit of inorganic material. Research has been conducted on the porosity of silica and how it can improve dielectric properties. There is a lot of research still going on ceramics, especially ceramic matrix composites as a dielectric materials, not pure ceramic matrix composite materials. Fluorinated silicon oxide composites. These are also the past dielectric materials. Fluorination of silica matrix can lower dielectric permittivity in ultra large scale integrated circuits. You can see ULSI, ultra large scale integrated circuits for dynamic random access memories and microprocessor units. So we can use this type of ultra large scale integrated circuits, the fluorinated silica as a material. A combination of bismuth oxide, silica, alumina, and magnesium oxides is used as a ceramic fillers in dielectric layers, which can have a permittivity values between 8.8 until 9.4 at a frequency of 13.4 gigahertz. Most of the time, we cannot simply say the dielectric constant 3.8 or 8.8 at what frequency, because dielectric depends upon the frequency. Always we have to say this much amount of dielectric constant related to what is the frequency. So a dielectric resonator made from calcium titanate powder has permittivity values between 40.5 and 40.7 and a resonant frequency of 6.55 gigahertz. So you can see here The dielectric resonator made from calcium titanate powder. The dielectric constant value is 40.5 until 40.7 at a frequency of 6.56 gigahertz. So always, as I said before, dielectric constants is not a single number. It is always related to the particular frequency. Oxide glass ceramics composite. It's also materials in the past. Oxide glass ceramics can be used in interlayer dielectric substance for solid oxide fuel cells. We know that these days, a lot of developments in battery as well as fuel cell. So one of the materials used in the fuel cell is dielectric material. So oxide glass ceramics can be used in interlayer dielectric substrates for solid oxide fuel cells, high temperature ceramics filters, and structural ceramic compound. Apart from this, ceramic fillers made from a combination of bismuth oxide, silica, aluminum, and magnesium oxide can be used in these samples as well. So it's a kind of adding dopants or foreign elements to increase the dielectric properties of various materials. Oxynitride systems. That is, oxynitride is a past dielectric material. You can look at this point. Borophosphorate silica ceramic is a candidate for electronic packing due to its excellent electrical and physical properties. These oxide nitrates are used for electronic packing due to its excellent electrical and then physical properties. And it has high thermal expansion coefficient of 45 to 55, 10 to the power of minus 7. Its dielectric constant of 3.8 to 4.5. So, oxide nitrates are the type of oxide silicate glass ceramic containing nitrogen. Thin film based lead titanate. This is also the past, the used materials. Lead titanate based materials are ferroelectrics with a range of applications in thin films, including using trams. So borophosphate silicate ceramic glass is a candidate for electronic packaging due to its excellent electrical and then physical properties. So now, whatever just now we saw, all our past dielectric materials is mostly on ceramics. You can look at this point, the ceramic type of ceramics used in the past as a dielectric material. Oxide ceramics like aluminum oxide, magnesium oxide, zirconium oxide, aluminum oxide. Silicate ceramics, porcelain, magnesium silicate, and then malmit. Corpide ceramics, we got lot like boron corpide, tungsten corpide, silicon corpide. Nitride ceramics like silicon nitride, silicon aluminum nitride, and then aluminum nitride. So these are various past materials as a dielectric. What is the drawback here? That's what we want to know. What is the drawback? You can look at this point here. We are taking as a powder, that is raw material. Material preparation, it undergoes like pulverizing, mixing, filtering, granulating, plasticizing, spray drying, and then goes to the molding process, dry pressing, extruding, injection molding, isostatic pressing, and then comes to green machining, like by means of milling, drilling, turning, and cutting, and then goes to the sintering. It's a debindering and then sintering. So firing takes place. You can look at the temperature 900 degrees centigrade to 1750 degrees centigrade. This is a major drawback. How to get this 900 degrees centigrade until 1750 by means of electric furnace or by means of coal-fired furnace or oil-fired furnace. So it gives a lot of CO2 emission. That's what the problem starts. Why it is not sustainable. Ceramics are now why it's not sustainable. During sintering process, it needs huge amount of high temperatures limits, 900 to 1750 degrees centigrade. After that, what happened? After sintering, it goes to finishing by means of grinding, lapping, polishing, honing, metallizing, glazing, and then assembly. Finally, it comes to quality assurance, like testing. They use like optical, dimensional check detection, and strength. For all this process, you can look at as a picture here. From the process of ball milling, the ceramic raw material, ceramic powder, it goes to ceramic slurry. Until it goes to all the process, comes to the termination firing. So, what is happening exactly? You can look at this process here, the process model. Whenever there's a process takes place, ceramic dielectric metals manufacturing, there's some amount of input of energy, input of water, some amount of raw materials, consumables, packing. All these inputs goes into the manufacturing. It converted into product. During this process, it gives a lot of pollution. air pollution, water pollution, and then land pollution. You can see any process, especially the ceramic manufacturing, it gives a lot of CO2 emission because it needs high temperature, 900 to 1750 degrees centigrade. Due to this, what happened? Climate change problem. As I said before, climate change refers to long-term shift in temperature and weather patterns. Climate change is one of the world's most pressing challenge. Everywhere, it's a pressing challenge. Human emissions of greenhouse gases like carbon dioxide, nitrous oxide, methane, and other gases causes this CO2 emission. Especially these particular ceramic dielectric materials, it gives a lot of carbon dioxide, CO2 emission, because we need high temperatures from 900 degrees centigrade until 1750 degrees centigrade. So we need to use either coal-based furnace or oil-based furnace or electric furnace. But anyhow, it gives a lot of CO2 emission. That causes, we know that due to the causes rapid industrialization, energy use, agriculture practice, deforestation, consumer practice, livestock, transport. What are the effect of this climate change means? Like rising temperatures, rising sea levels, unpredictable weather patterns, increase in extreme weather events, land degradation, loss of wildlife and biodiversity. Not only these effects are, apart from there's a social impact also. What are the social impact of climate change? Displaced people, poverty, loss of livestock, hunger, malnutrition, increased risk of diseases, global food and water shortage. What are the major causes? You can look at this picture from 1990 until 2050. The major CO2 emitter is CO2 by means of power. Because still we are based upon coal-fired power plant. We are not going to renewable only to 20 to 30%. We know what are the renewable energy like solar, wind, tidal, geothermal, hydro, nuclear, those were renewable. But this non-renewable thermal-based power plant, especially coal-based power plant, it gives a lot of CO2 emission. That's what higher CO2. So how to mitigate this? Yes, we can able to mitigate this issue. Can look at this industrial revolution. When we can talk about industrial revolution, 18th century, the industrial revolution 1, that is industry 1.0, mechanical production equipment powered by steam. We know that steam, it's not easy to get steam. We are converting water into steam. For this, we need a huge amount of heat energy. How to get the heat energy means by means of burning a lot of CO2, coal. So we started to pollute our earth surface since industry 1.0. Industry 2.0, mass production assembly lines requires labor and electrical energy. As I said before, even though it's an industry 2.0 or 19th century, here we discovered electrical energy. So electrical energy based upon thermal power plant. It burns a lot of CO2, lot of oil. Again, it gives a lot of CO2 emission. Industry 3.0 during 20th century, automated production using electronic and IT. Again, it uses electrical energy. Currently, we are talking about industry 4.0, intelligent production incorporated with IoT, cloud technology, and big data. Still, our energy, especially the electrical energy based upon coal-fired power plant, thermal power plant. So 80% power production, 70 to 80% still based upon coal-fired power plant that gives a lot of CO2 emission. But only we can able to replace, we can able to produce 20 to 30% of renewable energy at this moment. We are still developing technologies for solar, still developing technologies for wind energy, geothermal. We are talking about hydro. No? So these are developments taking place to develop power in terms of CO2 emission, to reduce CO2 emission. Apart from this, we are having a lot of pollution as well. Air pollution, water pollution, soil pollution, and then noise pollution. You can look at this picture here or here. Industrial process, industries gives a lot of CO2 emission. Transport also gives a lot of CO2 emission because most of our transport are based upon still fossil fuels like petrol, diesel, or kerosene, some other device as well. That's what it gives a lot of CO2 emission. What is sustainability? We know that the term sustainable development is a development that meets the needs of the present without compromising the ability of future generations to meet their own needs. In simple term, we all know that we have to use the natural resources for ourselves. At the same time, we have to keep the natural resources for the coming generation. That is called sustainable development. This concept suggests that in addition to economic performance, a company must also account for its focus on its environmental and then social performance to be truly sustainable. These days, manufacturing companies are focusing only on profit, only economic point of view. They never bother about what is happening to the people around them, what is happening to the environment. So, what is sustainable developments? We have to equally develop among three important pillars: economy, environment, as well as society. If the society develops, economic develops, environment develops, that is called sustainable development. We need to focus, we need to take action for all these three before you can take any initiative. That type of development is called sustainable development. That's what United Nations developed sustainable goals. There are 17 sustainable goals according to United Nations. They are parked under three important pillars. Under economic pillar, we can talk about no poverty, zero hunger, good health and well-being, decent work and economic growth, industry innovation infrastructure. Under environmental pillar, we can say clean water and sanitation, affordable and clean energy, responsible consumption and production, climate action, and then life below water and then life on land. So this is under environmental pillar. Under social pillar, we got quality education, gender equality, reduced inequalities, sustainable cities and communities, peace, justice, and strong institutions, and then partnership for the goals. So these are the important pillars for sustainable development. So each and every country these days working towards achieve these particular goals. These are under United Nations 17 Sustainable Development Goals. What are the present dielectric materials? Because we got past, we got due to the problem. Now, what are the present currently used? Currently, we are using a lot of polymers as a dielectric material. The polymeric materials we can classify. Polymers are used in dielectric applications due to their high flexibility, chemical stability, cost effectiveness, and ease of fabrication. You can look at this point. Before we use ceramics. Ceramics needs high temperature to manufacture, but here ease of fabrication. Polymers maximum melt within from 0 to 200 degrees centigrade at 250 maximum. That's what polymers are used in dielectric applications due to their high flexibility, chemical stability, cost effectiveness, and ease of fabrication. However, polymers have low thermal stability and low dielectric constants and limiting their potential application. Ceramics got higher dielectric constant values, 40.5, 7, 8, 9 like that. But polymers have low dielectric constant values. So, to increase the dielectric constant of polymers, nanocomposites and inorganic fillers can be introduced. We can add some kind of fillers to increase the dielectric constant of polymeric materials. So, polymer dielectrics are used in microelectronics and must meet high thermal, electrical, and environmental stability requirements with a low moisture intake. So presently, we are using a lot of polymers as a dielectric materials, but still they got some kind of drawback. Okay. What are the various polymers used as a dielectric material? For example, the first one, aromatic polymeric dielectric materials, polyamide. Polyamides are aromatic polymers with low dielectric constant and good electrical properties. Polyamide dielectric constant ranges from 2 to 3.5 with the dielectric loss 10 to the power of -3. So polynitriles are also aromatic polymers with a low permittivity and excellent thermal stability used in microelectronic packaging. You can see the paradigm of polymer-based dielectric materials. It's miniaturization of equipment, adapt to extreme working environment, high energy density and high voltage application, safety and durability. Okay, and then higher energy density. Polymers got a lot of advantages compared with ceramic as a dielectric materials. The second material is silicon-based polymeric dielectric material. Silicon-based polymeric dielectric materials. Polymers with a low dielectric constant are applied in interlayer dielectrics. Among the dielectric material, they can use as a interlayer. Fluorine atoms can be bonded stoichiometrically to increase electrical behavior in these polymeric dielectric materials. Example, silicon-based polymers are the hybrid mix with the formula of RSO3. So we can use this type of polymers, fluorinated polymers or silica-based polymers as a dielectric material in the various application, especially microelectronic. Microelectronic application, they got lot of polymers as a dielectric materials. And then fluorinated polymers like polyamides are aromatic polymers with promising electrical properties that can be modified with the fluorine to improve dielectric properties. You can see the simple or pure polyamides. We can modify the properties of the polyamides by using fluorination. So we can able to increase the dielectric properties. Fluorination introduces non-polar characteristics to the polyamides and reduces polarizability, leading to decrease in dielectric constant. Okay, so we can able to alter or tailor-made the properties of the polyamides by using fluorination. Polyamides have high chemical and thermal stability, and addition to fluorine makes them suitable for performance enhancing electronics. So we can use fluorinated polymers also material at present. And then we got low dielectric constant polymers. What is the term low? K means low thermal conductivity, or we can say dielectric constant. Low K polymers are the class of polymers that have relatively low dielectric constant, typically less than 4.2. Those polymers have less than 4.2 of dielectric constant or comes under the category of low K polymers. These polymers are used in variety of applications, including insulation systems in electrical equipment, microelectronic packaging, and interlayer dielectrics. Low K polymers can be further divided into two categories, thermoplastic polymers and then thermoset. We all know that whenever we can talk about polymers, they classified into three categories, thermoplastic, thermoset, and then elastomer. So these low K polymers again classified into thermoplastic and thermoset. For example, you can see examples of thermoplastic polymers include polyethylene, polyvinyl chloride, polypropylene, and polyamide. Examples of thermoset polymers include epoxy, polyesters, phenolic, and then silicone resin. Dielectric polymers in high voltage application, where we can use. You can look at this point. Crystalline or semi-crystalline. We all know that what is meant by the crystalline or amorphous structure. Crystalline or semi-crystalline thermoplastics such as low density polyethylene, ethylene vinyl acetate, and polyester ketone have used in high voltage insulation devices due to their high melting temperatures and crystalline and amorphous phase. So for a high voltage application, we can still use various types of polymers. Examples of thermosetting plastics used in dielectric application include epoxy resin, polyester resin, glass fiber infused polyamides, and polyurethane. Elastomer, as I said before, thermoplastic, thermoset, and elastomer. Elastomer polymers used in dielectric application include styrene butadiene copolymers, polybutadiene, and EPDR. Okay, these polymers have natural dielectric constant, but their suitability for high application is scrutinized. So it depends upon the type of polymer, either thermoplastic or thermoset or elastomer. We need to scrutinize according to the application, whether it's a high voltage or low voltage, or high dielectric constant or low dielectric constant. Low K epoxy materials. Epoxy, you can see here, epoxy resins are widely used in various fields due to their excellent mechanical and electrical properties. Mostly, yes, epoxy is used as a common purpose, not only for electrical application, even go for mechanical application, they got epoxy as a material. Epoxy resins can be derived from renewable natural sources such as carbohydrates, starch, protein, fat, and oils, which makes them more environmental friendly and sustainable. Because before, epoxy is a kind of unsustainable. But these days, epoxy resins are derived from natural resources like carbohydrates, starch, protein, fat. So it's a completely biodegradable. We can say it's a environmental friendly or sustainable. So the ability to adjust the fluorine content in epoxy resins can also significantly impact the material surface energy. So we can see here, we are taking as a epoxy as a major element, and we can do the fluorination that enhances the properties of the epoxy. So it is used as a dielectric material, especially as a low dielectric materials and their applications. What are the issues in the existing material? For example, at present, the primary problem is traditional dielectric metals made of inorganic substance like ceramics. Inorganic metals have higher thermal properties. Temperature requirements lead to extreme end of processing temperature. This is the primary problem is from ceramic. So we gone to secondary. Second is polymer. Polymers are gaining wider use as a dielectric materials due to their easy processing, flexibility, able to tailor-made for a specific use and better resistance to chemical attack. But polymers also got some drawback. What are the drawbacks of polymers? Coefficient of thermal expansion is relatively larger than the ceramic materials and susceptible to atmospheric and hydrodynamic degradation, as well as weak mechanical strength. Then what is the solution? The solution is composite materials. So natural fibers reinforced polymer matrix composites is synergistic between properties that is applied as a dielectric materials. So the primary problem starts with the ceramic material. This is a past material. The present material is polymers. So we are going to have now the future coming materials, sustainable materials. What is a composite? Composite generally used in various applications. Composite gains traction in a lot of industries from architecture to infrastructure and automotive. Why? Because composite got a lot of advantages. They can able to replace steel. They can able to replace aluminum and other wood and granite. Why? Because composites are lighter than steel. Composites are incredibly strong. Composites are corrosion resistant. Composites are non-conductive. Composites are excellent at handling tension. Composites can create one-piece design. Composites are strong yet flexible, and composites absorb vibrations. You can see these are the composite application. Composites are classified into matrix types based upon a reinforcement type. Based upon matrix, they are classified into polymer matrix, metal matrix, and ceramic matrix. Based upon reinforcement, composites are classified into viscous reinforcement, particle reinforcement, fiber reinforcement, and then structural reinforcement. So these are the various composite classification. For example, what is a polymer matrix composite? As the name says, polymer matrix, polymer is a major portion. We can use either a virgin polymer or recycled polymer as a major portion matrix. Minor portion, we can add fillers or fibers, either natural fibers or recycled fillers, or we can use some kind of industrial co-product like woven or non-woven, chopped or long or short fibers, particle or hybrid. So you can take polymers, thermoplastic or thermoset, and then you can add some kind of fillers on it. We can use various processes like injection molding or extrusion or calendering process or hot press machine. We can convert into a different product. That's called polymer matrix composite materials. Especially why I'm talking about this polymer matrix composite means in our research, we are developing a lot of composite materials based upon, especially for a dielectric application, we are developing composites that is made of polymers matrix composite. Polymers along with natural fibers or polymers with ceramic fillers. We are developing a lot of materials for dielectric application at Swinburne University. These are the composite applications generally. They are applied in aerospace, architecture, automotive, energy, infrastructure, marine, military, and then sports and recreation. Polymer film capacitors, they also used present as a material polymer film. You can see the it's a film type. Polymer composites are materials made from a combination of polymers and other materials such as inorganic compound or a filler. These composites can be designed to have specific electrical properties such as high dielectric constant and low loss, which make them useful in advanced electrical application like film capacitors. Polymer composites with a high dielectric constant and low loss are highly desired in this application. Most of the applications, especially for electrical and electron applications, we need to have high dielectric constant and low losses because they have high energy densities, which allows for miniaturization. Because we know that these days the device, we want to reduce the size of any device. We know size of the TV before these days, even size of the cell phone. So we want to minimize, we want to reduce the size of any object. We need to have high energy densities. How to get the high energy density means it must have high dielectric constant and low losses so that we can go for miniaturization of the particular product. Epoxy-based composites, as we said, epoxy resins are thermosetting polymers because we know the difference between thermoplastic and thermoset. Thermoplastic, we can go for recycling. Thermoset cannot do that. So it's a non-biodegradable. So epoxy resins are thermosetting polymers that are used in low-K dielectric applications due to their inherent properties such as high adhesion strength, electrical resistance, and mechanical properties. They can be modified with the thermoplastics or inorganic compounds such as ceramics to improve their properties. Yes, we can go for it. These modified epoxy resins can be used in a variety of applications, including coatings, additions, electronic materials, and polymer matrix for fiber reinforcement. Dielectric materials for natural fibers. As we know, it's a natural fiber, got a lot of properties. One of the properties is dielectric. So, dielectric properties of natural fibers are influenced by various factors. For example, what is natural fiber? We know this banana fiber, simple example, is a natural fiber. We can go for various kinds of natural fibers, but all based upon what type of fiber, structure, chemical composition of the fiber, humidity and moisture content of the fiber, presence of impurities or defects in the fiber. In addition, the processing and treatment of the fibers, such as chemical treatment or physical modification, can also affect the dielectric properties of fibers as well. That is natural fibers. The use of natural fibers as dielectric material in composite materials can offer several benefits. When we can use these natural fibers, the benefits includes low density, low cost, good mechanical properties, and sustainability. So, however, it is important to carefully consider the dielectric properties of natural fibers in relation to specific application, as the dielectric properties can vary significantly depending on the above mentioned factors. So, the dielectric properties of natural fibers influenced by these factors: type of fiber, structure of the fiber, chemical composition of the fiber, humidity and moisture content of the fiber, presence of impurities. So how to choose it? You can see dielectric property depends where factors. These are the factors where the dielectric property depend. The dielectric and mechanical properties of natural fiber reinforced polymer composites are affected by number of factors, including fiber content, fiber size, temperature, and moisture content. You can look at this point. The dielectric and mechanical properties of natural fiber reinforced composites or polymers influenced or affected by various factors. First one is fiber content, whether 10%, 15%, 20%, 25%, fiber size, temperature, and moisture content. At the same time, the fiber content and size can affect the adhesion between the fibers and polymers, as well as the mechanical properties of the composite. Temperature can affect orientation and polarization, therefore dielectric properties of the composite. Moisture content can also affect the dielectric properties of composites, with an increase in moisture leading to a decrease in the dielectric constant. Chemical treatment. So, there are a lot of properties of natural fibers affects the dielectric properties. The main ones are fiber content, fiber size, temperature, as well as the moisture content. So, it is important to carefully consider these factors in the design and manufacturing of natural fiber reinforced polymer composites for specific applications. For example, you can see what is sustainable material. Materials are sustainable if they do not strain the environment during their production, use, and disposal. So, we have to make a dielectric materials in such a way that it's completely biodegradable. Then we can say it's called sustainable material. Sustainable dielectric material. When we can say the term sustainable dielectric material means materials are sustainable, they do not strain the environment during their production, use, as well as disposal. Sustainable materials also create fewer long-term environmental problems. Simple example like air pollution, water pollution, soil pollution, like that. During production, noise pollution, lead to the healthier planet. So, the natural products like wood, bamboo, and other plant-based materials are sustainable because they grow naturally. Bio-based materials. You can look at this point here, bio-based materials. That is, bio-based means natural fibers reinforced polymers. Natural fiber reinforced polymer composites have gained a lot of attention in recent years due to their potential as sustainable materials with the good mechanical and electrical properties. These composites have a wide range of applications, including electrical and electronic applications, where their dielectric properties are particularly interest. So, these days, polymer matrix composites play an important role as a dielectric material. Biopolymers derived from biological resources are also being increasingly used in the manufacturing of green composites. So, this green composite also used as a dielectric material. You can see. thermoset green composite? Because here the epoxy itself, they made by using natural things. Example, plant or starch. You can look at this point here. Bio-based thermosetting plastics have been developed for renewable resources such as plant-based resins, vegetable oils, and oil-based monomers. They include bioepoxy resins, biophenolic resins, and biourethane. You can see here, before we know that epoxy, phenolic formaldehyde, urea formaldehyde, like that, those are derived from petroleum products. But these days, these epoxy resins, phenolics are derived from bio-based materials. That's called bio-based, completely biodegradable. They have the potential to replace traditional petroleum-based thermoplastics. You can look at this point here. They have the potential to replace traditional petroleum-based thermosetting plastics in various applications, including automotive and construction industries. So these days, scientists have discovered how to get the epoxy from the plant, how to get the resins from the plant or vegetable oils. So that's all completely biodegradable. That's called green composites. You can see thermosets. In addition to the bio-based thermosetting polymers mentioned above, they are often green thermosetting polymers that have been developed for use in composite materials. One example is phenolic formaldehyde resins, which can be made from renewable sources such as wood or agricultural waste. Because these days, researchers have started to develop a lot of cellulose from these natural fibers. So it's completely biodegradable. What are the various natural fibers? Just now I saw. You can see lignocellulose fiber. Based upon bast, we got like jute fiber, flax fiber, hemp fiber, rami fiber, kenna fiber, roslin, and then muslin. Leaf fibers like sisal, banana, abaca. You can see pulp and then agave. Fruits, oil palm, and then coil. Stack fibers, rice, wheat, barley, maize, and oats, and then tree. Wood fibers, softwood and hardwood. Reed, we are bamboo fiber, bagasse, corn, sabal, rab, isa, and the candy. And then seed fibers like kapok, cotton, loofah, and then milkweed. So these are various types of natural fibers available. You can look at this point here. Natural fibers have been widely used in various fields, including automotive, construction, packaging industries, due to their low density, high specific strength and stiffness, low cost, and good environmental capability. In addition, natural fibers can easily modified and functionalized through the various methods such as chemical treatment and surface modification of the fibers. That is possible. So these materials are also used as dielectric materials. This is one of our research. I can show you some samples in Swinburne. This was one of the master student work. There is an urgent and need for sustainable composite materials. You can look at this point. There is an urgent need for sustainable composite materials with superior dielectric properties to meet the demand for advanced materials in technology and biomedicine. So he used selection of natural fibers and nanoparticle blend into the biopolymer. The biopolymer selected was polycaprolactam, natural fiber jute fiber, nanoparticle silver nanoparticle. This aim of the research is, the primary aim of this research is to analyze dielectric properties of polycarbonate composites by incorporating both treated and untreated silver nanoparticles along with jute fiber. You can see this is one. This is a process fabrication of the PLA composite, calculating the mass of PCl required for the 4 moles in the, because we follow according to ASTM standard, the mole size also, the volume, and then mass, we can calculate density equal to mass divided by volume. After that, you can see considering an excess mass of PCl and finalizing the volume of acetic acid gaseal used, dissolving the PCl pellets in acetic acid gaseal by heating. And then we can got the acetic acid gaseal is evaporated. And finally, we can get this sample like this. This is completely biodegradable, you can say, because you can look at the ingredients, look at the materials. It's got a polycaprolactone and then jute fiber. Silver nanoparticle is added to improve only the dielectric constant value. So you can say it's completely biodegradable composite materials. This is one of the research. We got dielectric constant values. Dielectric constant for treated fiber. This is dielectric constant for untreated jute fibers. You can look at 12.83 at a frequency of 20 Hertz. As I said before, always dielectric constant related to frequency. You can look dielectric constant This is jute fiber loading. That is fiber content. 5%, 10%, 15%, 20%, and then 25%. You can look at the point whenever the fiber content increases, the dielectric constant also increases. You can look at the point where we can able to get highest value of 12.86 hertz under 20 hertz of frequency. This is for treated jute. Treatment, we can do like chemical treatment of jute fibers, or we can do physical treatment of jute fibers, or we can do mechanical treatment also. Depends upon the facilities available in our university or a research center, we can do that. You can see dielectric constant of untreated jute fibers. Untreated, how this lowest value, treated got highest value. We can see why. You can see this is nearly 12 point something. Here only until 8. This is untreated, this is a treated jute fibers. Always, as I said before, dielectric material, two important properties. We always prefer highest dielectric constant values and the low loss. That's it. That's a criteria to choose. So you can see the loss here, 0.06 at 2 megahertz at 5.8%. Here we can got 0.05. These are the formula for a silver nanoparticle. This is dielectric constant of treated silver nanoparticles, because we have to treat the fillers also. This is dielectric constant of untreated silver nanoparticle. You can see here the treated gives like 14.38, untreated gives 7.39 silver nanoparticle. Similarly, corresponding loss. This is the dielectric loss. This is the dielectric for untreated. So here you can show that both samples show that the treated fibers as well as the treated silver nanoparticle gives the highest dielectric constant. That's what we published the papers as well. Why? You can see the reasons why treated jute fibers show highest constant and highest losses compared to untreated. You can see here the term highest constant as well as highest loss. That is not a preferred one. We must have highest constant and then low loss. That's what we are still working on the research on it. Alkaline treatment, that is sodium hydroxide treatment. Fibers removes impurities such as hemicellulose and lignin, allowing more space for high water absorption, because jute fiber is hydrophilic in nature. This hydrophilic nature arises due to hydroxyl groups present in the fiber. Higher water absorption leads to the greater number of polar molecules, increasing dielectric constant. Untreated jute fibers have higher impurities content with less space available for water absorption. Similarly, we can go for silver nanoparticle with highest particle. You can see these are the fabricated device. We use a hot compression molding machine. This is a standard specimen preparation according to ASM standard. We have two different methods. We can, for example, we are dissolving the PCl in the acidic acid. We are converting pellet into liquid. Sometimes we can use a hot press machine to melt. Like this is, for example, this way you can use a polypropylene or polyethylene, either low density or high density. We use melt mixing method. This is also, we got facilities over here. We got facilities for curing process also at Swinburne University. And then we got a testing device. As I said before, the dielectric properties of the composite specimens are measured with the help of HP impedance analyzer E4980A. This is a parallel plate method. You can look at these are two plates here. So top and the bottom plate. The specimen were analyzed using conducting electrode method with the right metal electrodes. This is the LCR meter to measure the capacitance so that we can able to get what is the dielectric constant. The measurements are done using various frequencies. These are the facilities available at Swinburne University, Malaysia campus. At the same time, we do a lot of simulations. We do a lot of simulations for calculating dielectric values. We have to use some kind of tools, equations as well as, for example, effective medium theory is the most commonly used. Punchen equation also we can use, Lichtenegger equation. So these are the equations used by one of my master students to predict the dielectric value. At the same time, we can use a lot of methods to predict these values as well. Manufacturing, we know that whenever the manufacturing undergoes, it also gives a lot of CO2 emissions. The manufacturing sector significantly contributes to the gross domestic product of the country economy. However, this sector also contributes to the inefficient utilization of energy, because currently the manufacturing industries gives a lot of inefficient utilization of energy and increased carbon emissions, posing a threat to the environment. So what we need to take? Manufacturing sector include like primary metal, paper or chemical, petroleum, accounted for nearly 70% of the total energy consumption. So, manufacturing industries must take a necessary action to reduce the inefficient utilization of energy. For example, you can see the manufacturing sector has a huge role to play in creating products that minimize negative environmental impact and conserve the energy and natural resources. So we have to move from conventional manufacturing to sustainable manufacturing. What exactly is sustainable manufacturing? A systematic approach to eliminating waste by optimizing use and selection of resources and technologies, thereby lessening the impact on the environment. You can look at this point. What is meant by sustainable manufacturing? A systematic approach of eliminating waste by optimizing use and selection of resources and technologies, thereby lessening the impact on the environment. Sustainable manufacturing focus on both how the product is made as well as product attributes. Sustainable manufacturing includes things such as making products using less energy and material, producing less waste and using fewer hazardous materials, as well as products that have greater attributes, greener attributes, as such as recyclability or lower energy use. Okay. Currently, you can look at this, why we need to focus on sustainability, why we need to focus on huge development. When you can talk about the term trend or value chain or circular economy, you can look at in 1990, the population was 5.3 billion. 2015, it was 7.3 billion. In 2030, it will be like 8.5 billion. In 2100, it will be like 11.2 billion. You can see population increases dramatically. Okay, but we got only one natural resource, Earth surface. So the world population is growing exponentially. The world population is growing exponentially, but there is a finite supply of non-renewable natural resources. These resources are limited. We have limited amount of water resources. We have limited amount of wind power. We have limited amount of animal resources. We got limited amount of land, minerals, crude oil, precious metal, forests. So what happened? There is an upward pricing pressure on non-renewable commodities that have major impact on business forward. So the price increases. We all know that what was the petrol price few years back, like 1 liter of petrol, like 50 rupees or 60 rupees. These days, more than 100 rupees. Why? Because population increases dramatically. Demand is more, supply is less. So the cost of product is higher. So how to reduce this? We need to develop the technology. We need to go for circular economy. You can look at this point. The economy, linear economy, we are taking the raw material, making the product, using the product, and then waste. That's what linear economy. Currently, we are in the recycle economy. Take, make, use, recycle. We are using 3R principles, 5R principles, but that is not enough. We have to move completely to circular economy. Take, make, use, repair, recycle, or return or reuse. So there is zero waste. In case there is a waste present, we can able to convert that into useful energy. Waste collection to the plant. We can convert waste into fuel or convert waste into gas or convert waste into electricity. So that we can able to achieve the point of circular economy. You can see here, circular economy, how to achieve it from linear economy to circular economy by adopting 9R principles: recover, recycle, repurpose, remanufacture, refurbish, repair, reuse, reduce, rethink, and then refuse. By adopting this, then we can able to convert from linear economy to circular economy. These are the papers we published in 2025, this year. This is one of my PhD student, a review paper. If time permits, maybe you can go and download this paper. When you read this particular paper, you can get complete idea about what is dielectric material, past, present, and future. For example, review, classification, theories, and methodologies concerning bio-based polymer dielectric materials. This is published this year, January last month. Renewable and sustainable energy reviews, this impact factor like 16.2 something. So you can refer this particular paper. This is my PhD student paper, so that you can get complete idea about what is dielectric bio-based polymer materials. Another research, again the same journal, Renewable and Sustainable Energy, in 2022, a comprehensive review on dielectric composites, classification for dielectric composites. So when you can read this paper as well as this particular paper, both are review paper, definitely you can get complete picture about dielectric materials. So if you have any ideas, definitely you can develop, you can able to find the research gap. You can pursue your PhD or master's in composite materials. Other publications like Materials Chemistry and Physics, Applied Journal of Applied Polymer Science, we published 2 papers. These are the latest paper, 23, 22, and then 24 and 25 papers, Bioresources, Scientific Director as well. By concluding this one, by conclusion, natural fiber reinforced polymer composites have shown great potential in various industries and commercial applications due to their renewable, biodegradable, and low cost. These composites can be used in variety of sectors, including automotive, civil energy, power sectors, powertrain, electrical and electronic industry. They offer a range of physical characters such as good mechanical and electrical properties, ease of processing, and cost effective. With this, I can thank IPS College of Technology and Management for giving me this great opportunity to interact with 120 participants. Thank you, everyone. I'm ready to take a few questions. Thanks for the coordinators. Especially, I would like to thank coordinator Manoj for giving me this opportunity for contacting me regularly, updating all these details. Thanks, Manoj.
Thank you, sir. Dear participants, if you want to ask question, please ask.
Hello. Now I would like to invite Dr. Mudgal for vote of thanks.
Any participant have any query? Please ask. Okay, there is no question. Sir, continue.
Yes, sir.
Yes, sir. Dr. B.B. Mudgal, please, for vote of thanks, I would like to call you.
Hello. Once again, good afternoon, one and all present here. I, Dr. B.P. Mudgal, Professor, Department of Civil Engineering, IPS College of Technology and Management, Gwalior, on behalf of the organizing committee of the 6 days faculty development program on recent advances and applications of manufacturing in industries 4.0, extend my heartfelt gratitude to our esteemed keynote speaker, Associate Professor Dr. Ella Paran Jayamani, Discipline Leader and Faculty, Swinburne University of Technology, Malaysia, for his valuable insights during this faculty development program. He explained composites for dielectric applications in the past, present, and future. Sir, your expertise, deep knowledge, and engaging session have enlightened us and provided us with new perspectives that will surely enhance our skill and professional growth. I would like to express my thankfulness to across India for being part of this enriching. I thank you, the director and other administrative staff, management staff, for providing conducive environment for conducting such a wonderful session. Thank you all once again.
Thank you, sir.
Thank you, sir.
Thank you, everyone. Thank you.
Dear
We will see you again, sir, next event.
Sure, Dr. Manoj, definitely.
Yes, sir. Thank you.
Thank you very much, sir.
Now, Sneka ma'am, you will
Yes, sir.
continue.
Yes, sir. Dear participant, please stay online. Our next session will be started soon. In between, I want to give you some instructions. Dear participants, there is some important instructions for you. As we know, today is the final day of 6 days of 1 week FDP, Faculty Development Program. On this day, the quiz will be displayed on your login in ATAL portal at 8 p.m. to 9 p.m. It is requested to all please solve and submit the quiz in the given time. The minimum qualifying score of this quiz is 70%. The feedback link is also provided on your login on ATAL portal. Please fill and submit it within given time. It will also be appear between 8 to 9 p.m. Both the link will be disabled after given time. So it is requested to all, please submit both the quiz and feedback within time. It is mandatory for all. The certificate of this FDP will be based on your attendance and score obtained in quiz. It is minimum 70% on today. After submitting both, your certificate will be uploaded on your ATAL login. You can download from there. The instruction in the form of flowchart has also been given in WhatsApp group. So participants, please stay online. Our next session will be started soon.
আগে বুড়বক চলে যাবে তো
Dear all, please stay online. Our next session will be started within few minutes.
Ma'am, when quiz starts, ma'am?
Ma'am, it will take approximately maximum of 5 minutes. So please stay
After-
online.
No, ma'am. Quiz, ma'am.
Yes.
Quiz.
Quiz. The quiz will be available at 8 to 9 p.m. on your login at ATAL portal.
Okay, ma'am.
Ma'am, it is only for 1 hour. You have to solve the quiz and submit it within given time.
After 9, it will not be
Yes,
available,
ma'am.
ma'am.
It will be disabled.
Okay, ma'am. Okay.
Please stay online. Participants, please stay online. Our next session will be started soon. Please stay online. Our next session will be started soon. Before starting new session, I have some instructions for you. I repeat the instruction. Dear participant, there is some important instructions for you. The quiz will be displayed on your login in ATAL portal at 8 to 9 p.m. It is requested to all please solve and submit the quiz in the given time. The minimum qualifying score of this quiz is 70%. The feedback link is also provided on your login on ATAL portal. Please fill and submit it within given time. Both the link will be disabled after given time, so it is requested to all please submit both the quiz and feedback within given time. It is mandatory for all. The certificate of this faculty development program will be based on your attendance and score obtained at quiz on today. After submitting, both your certificate will be uploaded on your ATAL login. You can download from there. Thank you, and please stay online for our next session. Sir has joined. Namaskar, sir. Dear participant, please stay online. We will be started soon. Within few minutes, we will be started. Please stay online. Please stay online. Our next session will be started soon. Dear participant, there is some important instructions for you. The quiz will be displayed on your login on ATAL portal at 8 p.m. to 9 p.m. It is requested to all please solve and submit the quiz in the given time. The minimum qualifying score of this quiz is 70%. The feedback link is also provided on your login on ATAL portal. Please fill and submit it within given time. Both the link will be disabled after given time, so it is requested to all please submit both the quiz and feedback within time. It is mandatory for all. The certificate of this faculty development program will be based on your attendance and score obtained in quiz on today. After submitting both, your certificate will be uploaded on your ATAL login. You can download from there. The instruction in the form of flowchart or has also been given in the WhatsApp list. Thank you, and please stay online. We will start it soon. Please stay online.
Good afternoon, sir.
Yeah, good afternoon, Professor.
Good afternoon, sir, and
Yeah.
welcome.
Thank you, madam. Can I start or?
Yes, sir. Let me introduce.
सुशील सर, सुशील सर को होस्ट बना दीजिए. Please make the co-host. सुशील सर.
Sir, Ravi sir is co-host.
He is, sir. So we will start.
Yeah. Thank you, madam.
Good afternoon. Good afternoon, all. So we are proceeding for our 12th session of 6 days faculty development program. We are honored to have with us Dr. Mamila Ravi Shankar, Professor IIT Tirupati, who will be sharing their invaluable insight and expertise throughout this program. So I invite Professor M. Ravi Shankar to deliver his talk on smart abrasive flow finishing system to finish complex additive manufactured features. But before his speech, I take this opportunity to present bio-sketch of Dr. Mamila Ravi Shankar. Dr. M. Ravi Shankar is currently a professor in the Department of Mechanical Engineering at IIT Tirupati. Here, he served nearly 7 years as assistant professor in Department of Mechanical Engineering at IIT Guwahati before he joins in IIT Tirupati. He did his B.Tech from Sri Venkateshwara University, Tirupati, and M.Tech as well as PhD from IIT Kanpur. He has published over 80 in internationally reputed journals, 150 international conferences, 10 patents, 5 edited books, and 15 book chapters. The knowledge transfer of his patents is already transferred to India's leading research laboratories such as CMTI Bangalore. He guided 7 PhD, 32 M.Tech and 40 B.Tech students. Currently guiding 7 MS and 20 PhD students, he is the editorial member for IMechE Journal of Micro Manufacturing and guest editor for International Journal of Precision Technology. He is recipient of prestigious awards such as Institution of Engineers India, Young Engineers Award 2015 in Production Engineering, Indian Society for Advancement in Materials and Process Engineering, ISAMPE 2011, and finalist of Indian National Academy of Engineers, Young Engineer Award 2014 in Mechanical Engineering. He and his student received 4 Best Papers and 3 Best Poster Awards in national and international conferences. Apart from academic awards, he has also received Institute Dues of IIT Kanpur for the year 2009 for his outstanding games and sports achievements. Thank you, and it's over to you, sir.
Thank you, madam. It says sharing is not turned on. Send request. Yeah, I got it now. I got it now. Can you able to see?
Yes, sir. It is clearly visible.
So thank you, Manoj ji and Snehika ji. Okay, so
Thank you, sir.
thank you for giving the opportunity to showcase what we try to do at IIT. And yes, I'm switching off. Yes, yeah. So I'm going to talk on abrasive flow finishing, which is my core area, where we try to do many things in it. However, today's lecture is pertaining to additive manufacturing components, what we try to do, and similar to the same oriented objects and other things. Okay. So in my lab, currently the resume is whatever I have given is February or 2024. So which is almost a year back. Sorry for that because I have that one only. I have not updated after that. So currently I have more than 20 and PhD 20 odd. I think I have 28 PhD it seems. Okay, and at the same time I crossed already 110 or 120 publications. So regarding this, I have five verticals basically. So one is micro machining and nano finishing group, which is our core area of competence, and sustainable in manufacturing, which is my expertise again because I did in sustainable manufacturing in my MTech at IIT Kanpur. Before I moved to PhD in micro nano manufacturing group in IIT Kanpur itself. So I was doing at Professor X.K. Chaudhary group, and later I moved to Professor V.K. Jain sir group. So bionanomaterials, it is one of the area that I like. See, everybody has a researcher. So you have your wishes and wills. So I want to become a doctor. Unfortunately or fortunately, I couldn't become because of my poverty at that time. So, but however, my love towards bio is still intact. So I like biomaterials, biomedical and other things. So I work it. Additive manufacturing and smart manufacturing. Yeah, these are the some of the inter departmental things normally most of the people they can explore definitely whether you are from mechanical engineering, whether you are from a electronics engineering, whether you are from a chemical engineering or so additive manufacturing is one of the core competence where you have if you have a core competence you can adapt to additive manufacturing. So smart manufacturing, yeah, many people do smart manufacturing in many ways. Our way of doing smart manufacturing is one of those ways. So we try to do temperature measurement, force measurement, and so on. So that is also a part of smart manufacturing, but our way is developing the smart machines, and we develop HMIs, human machine interfaces, for us. So the smart. So I was looking at this one. The smart is a in my view. Say I don't have others view. Just for example, I have a lathe machine. Fundamentally, lathe machine is a machine where there is a tool, workpiece, rotation, head stock, tail stock, everything. Once I know the concept, everything, I can make it by adding some electronics to it, adding some sensor to it, and other things. However, as a mechanical engineer, fundamental machine is more important. Building the fundamental science of the machine is more important. So adding to the smart to it is one vertical only. It is not the complete solution. However, in my view, that is only some part of it. Okay. So the most important part, for example, if you see the physics is most important. Once you know the physics, automatically you can make algorithm according to it. The same thing. So the smartness in our work perspective is I have an abrasive flow finishing process where it can do some of the motions, some of the movements and so on. So how can I control using computer numerical control or sensors or that this? So that is how we look at the smart manufacturing. Okay, so I understand you people are from Madhya Pradesh, Gwalior in particular. I was so this particular smart I learned or I take my assistance is one of the India's leading smart manufacturing person or faculty at IIT Delhi. He is native of Gwalior. Okay, he is none other than Professor Sunil Jha. I don't know, many of you may know him, Professor Sunil Jha of IIT Delhi. So he is my senior at Professor VK Jain's lab. And at this moment of time, when I take the concept of smart, it is my privilege and it is my honor to tell about my senior because he is also from Madhya Pradesh and Gwalior. When I, as a student, he is also student. So I used to talk to him, sir, how you are going? Sir नहीं बोलते थे वो सर, दादा बोलते थे. So दादा कैसे जा रहा है? अरे कुछ नहीं यार, कानपुर में 5:30 बजे एक ट्रेन आती है. वो हर स्टेशन पे रुकते रुकते ग्वालियर पहुंचती है सवेरे 6 बजे. तो 12 घंटा चलती है. सो मैं यहाँ पे साइड अपर में जनरल में ऊपर चढ़ के सो जाते हैं और उधर उतर जाते हैं. सो दिस इज हाउ. सो I had a fascinating conversations with him. This is a early stages conversation which I am talking about 2002, 2004 like that. Also almost all 22 years back. Okay, so आपका घर का आदमी one of the biggest smart manufacturing guy. I don't know if you, I'm sure that you may know many of you him. So still, I think his parents are there in Gwalior. I think I don't have much idea. So sustainable manufacturing group, micro manufacturing group. So I said we work mostly in manufacturing. So very intricate details of micro manufacturing for drug eluting stent applications, for biomedical applications, nuclear applications. And so these are the things that we have done. So we have some of the things we have done, some of the things are similar lines we have done, but we don't have right to showcase. That's why sometimes we generalize to show what all things are available on the internet. For example, we have done drug eluting stents that I will show you at the later the stage. How do we do micro machining and on smart materials? Normally, this will be done on a nickel titanium alloys, which is about a smart material, which you know that which normally placed inside the heart, which is for cardiovascular application and other things. Nuclear back-end fuel cycle, which is the one of the earlier projects that I did for Baba Atomic Research Center. So on micro machining of high aspect ratio, 1:200 holes, 1:200 is 1 mm is the diameter and 200 mm is the length on a rod of 24 mm stainless steel SS304 and a pitch circle of 16 mm. So it is not that much easy. Okay, so sophisticated tools are required to manufacture that and other things. That is a practical you can see here. This is a schematic diagram of the cross section and original image is like this. So what we developed is what are the rod that you are seeing at the bottom. So the purpose of this one is used for nuclear back-end fuel cycle. Nuclear back-end fuel cycle means, so whenever nuclear fission reaction completes, so when there is a nuclear waste which need to be discarded or something, with a little bit of knowledge that I have. So from there, they can generate even 7% of nuclear energy, which can light a city like Mumbai for 3 days. So that is the sophisticated application that they do, but this is just a small part of it. So microfluidics and other things we can do on any type of materials and other things for automobile applications and for nano coatings and so on. Okay, so this is a machine. Particularly, whatever you are seeing, it's not the right machine that we have. We have an advanced version of this one. So whatever you are seeing is DT100i. I mean, say what you are seeing, the machine is DT100 basically. So what we have at IIT Tirupati is DT100i, which is an intelligent machine. So it has mechanical micro machining like micro turning, micro milling and other things. Apart from it, micro ED milling, micro drilling, micro EDM drilling, micro wire EDM, micro wire EDG, dissecting EDM. This is all there. Apart from it, we have 3 additional features actually in an intelligent machine that we have. One is micro lasers, which we have, and high speed milling we have, which rotates at 60,000 RPM. At the same time, one of the sophisticated things that we have is simultaneous EDM ECM is there. So simultaneous EDM ECM, normally people in normal language they say ECSM, electrochemical spark machining, which is a combination of EDM and ECM. So many people developed the laboratory scale. Definitely, due credits are given to them. So, however, when the customer comes, they want very high accuracy and other things. That's why we procure that attachment. That attachment worth about more than 50 to 60 lakhs. So this particular machine is costing us around 3 plus. Okay, almost all when it landed at Tirupati, it is like maybe touching like 3.5, so on. So 3.5. So what is the capability of this machine? What is the capability of this machine is you can make micro turning, the same thing that you can use for micro EDM. Okay. So the tiny technologies you can do for any type of pins you can develop, array of micro pillars you can develop, micro gears for watches you can develop. And whatever you are seeing in the same image as well as a 3D image that you are seeing here, a flower-like structure. So that is shows the capability of my electric discharge machining and simultaneous EDM and DC, which I can explain you much better here. So when I'm doing a micro EDM process, the surface is like this. So simultaneous EDM and ECM. So whenever I want to see this one, it reduces from 142 nanometers to 28 nanometers. So when I am measuring at a very, very minute area, if I am measuring at a larger area, you may end up with 0.2 microns, 0.1 micron, and so on. Okay. So simultaneous electrical discharge chemical machining, which is combination of EDM and ECM, basically. So that's why, so it has lot of other features which makes for metals to do for sensor applications or placing the sensor applications. It is very, very good actually. Apart from I was saying, no, so we can do the laser micro texturing, laser micro machining and other things. That particular machine is there up. So any of this is we have done on a different machine, and we have at IIT Tirupati a 200 watt nano lasers from Trump, and that can do laser texturing, laser polishing, laser micro machining, and whatever if you want laser assisted machine. So on it will do. Okay. So apart from it, we have 3 coating systems that we have at IIT Tirupati. One is RF Mactron sputtering. Whatever the coating that you want to do, you can do. Second is DC pulse DC sputtering is we have that also you can do. And the RF sputtering, first one I told is single target one. So we have this is what is a single target one that you can see here. So my substrate is here on the top side, and it is the target where plasma is generated and going and coating on the substrate basically. Okay. So in the other case that we have recently procured a machine that has simultaneously 2 targets basically. If I want to coat on silicon or a glass substrate like a copper and like titanium, so you can coat both simultaneously. Okay. So having ability is for 4 type of targets. Since currently we just operating at 2 targets and so on. So this is how whenever you coat it, how the microstructure look like and so on. Okay. So interfacial bonding, coating and other things. So most importantly, as a mechanical engineer, the most of the people will not look at is the basic fundamental. For example, from here, the dendritic structure and other things is definitely a good thing that people will do. So when you go to EDS, energy spectroscopy, so normally people will do is point analysis, a line scan, area scan. So these are the three predominant things normally people do, definitely. But there is another option normally will be available in EDS, which is very minimally explored, that is called elemental mapping. In a line scan or area scan, for example, the first one, you see CL, coated layer, and transmission layer TL, and substrate is there at the bottom. So if you do area scan, normally you will get a spectrum. So the spectrum shows what is the quantity of alloying elements or what is the quantity of these, that, and other things. It will definitely tell you. So that's good for that. But if you go to elemental mapping, you will also get this type of particular details. At the same time, you come across where that element is there. For example, if you see calcium, okay, phosphates, titanium, oxygen, aluminum, Ti6Al4V, what is a substrate? On top of it, we have coated hydroxyapatite. Okay. So now you can see hydroxyapatite is Ca10 PO4 whole power 6 OH twice. That is nothing but calcium and phosphate. So these are the things that you can see. The calcium is dominating on the top side and phosphate is at the middle, and still it is there. And you can see here titanium substrate is dominating. So that means that clearly shows where titanium particles are there, where calcium phosphates are there, where is the aluminum is there, and other things are predominantly known. So then we can do the cell culture on top of it. I mean, say in vitro cell, it's normally biocompatibility tests that you can do. These are the flower type of structures. This will show you that our material is biocompatible and so on. Not only that, we also do after coating this the tribology test. So what I don't, if you, so you can see here, a lot of tribology experiments we try to do on variety of materials. Currently, we are doing an additive manufactured thing. And it's just I want to tell you that we have the facility and we have the facility for 3D surface profiling also. So those people who want to use our facilities like micro machining facility or 3D profilometry or tribology and so on, we have the facilities. So apart from it, we have also composites lab where we try to develop biodegradable implants. And as I said, no, Rome is not built in a day. So I don't know why it is. Okay, so the making the implant as per the ASTM standard takes sufficient time. So once you do all these things, then you can optimize the composition, optimize the dye as per ASTM standard and other things. Now you can make cancellous screws, critical screws, 10-min pins, plates, staples, and so on. Okay. So apart from it, we also do the injectable scaffolds, which normally I do very little with my second part. So my wife do mostly, she is the medico, so she do a lot of things. And in combination with my wife, we try to do some of the 3D bioprinting and other things. Okay. So with this, I am coming to additive manufacturing group, which I am going to talk on today. Okay, so additive manufacturing, because of the time constraint and other things, I am not going to talk much because we try to work on composite 3D printing, which is funded by ISRO. So we also do ceramic 3D printing, which is not part of this particular presentation. However, we try to do ceramic 3D printing also. One of our student has submitted the thesis on ceramic 3D printing and joined IIT Delhi as a postdoctoral fellow. So just 2-3 months back, he has just completed his thesis. So ceramic 3D printing also we do. So we also develop a lot of consumables because we are looking at the product level. Okay, so we want to showcase the products and so on. Okay, so what is the basic problem of additive manufacturing? The basic problem of additive manufacturing is its surface morphology and surface metallurgy. Indirectly, it is surface integrity. Whenever you take any surface of 3D printed one, the simplest 3D printing that you can assume always is laser powder bed fusion process, where you are assembling one particle by another particle. In this way, whenever you are assembling, there is a exposure of hemispherical structure on top of it. So that hemispherical structure can be depend on what is the laser power, scan speed, so on, so on. Okay. So, however, you cannot avoid complete geometry of the hemisphere that is forming, or there may be a deballing also. For example, if you take any particular component normally, if you take, there will be a first and foremost is adhered particles will be there. So these are called balls, and you need to remove those things whenever you want to go ahead with finishing. So because of that, what will happen? The process of removing this is called deballing. So deballing is required for that. So next, if you see, once you remove these spherical particles, you have roughness basically. So roughness and waviness. So the low frequency, high amplitude is what is waviness is all about. High frequency and low amplitude is all about your roughness. Okay. So some customers want shining, because not only finishing, they also want a good shiny surface. Chamakna hai component ko. So in some sense, whenever there is a commercial component like knee implant, hip implant, and so on, so the people want lustrous. So microstructure, I want a columnar structure, I want a dendritic structure, I want that, I want this, I want a spherical structure, uniform structure, fine structure. A lot of requirements come from the industries to industries. Flatness. So some of the samples require flatness and maximum peak to minimum value. So nowadays in additive manufacturing, people also ask, apart from RA value, average center line value, CLA, center line average value, they also ask maximum peak to minimum value, because whether you are removing the balls or not is also a question mark. And residual stresses, compressive residual stresses, and so on. So what we try to do in this particular thing is this. Whenever you 3D print it, doesn't matter whether you are printing in a 5 crore machine or a 10 crore machine, if you don't do the post finishing process, so that particular component is just a showpiece for you. So किसी को दिखाने के लिए काम आएगा. Okay. So what we try to work on is how the complex surfaces can be polished or finished. So the first and foremost thing is, whenever you want to go with respect to additive manufacturing, so you will go when there is a complexity in manufacturing the product. If that complexity is there, finishing itself is a very complex. So that is what is all about. So these are all the surfaces which are very complex in external surfaces. Anyhow, we are going to see the internal surfaces also. Okay. So first, what our group do is, this is the overview of liquid-based additive manufacturing, let's say finishing processes, where abrasives are not used. So this is called abrasive-less finishing process. The first process is chemical polishing. So we try to work on chemical polishing of the components. So what we try to do is, we try to make a elementochemistry. Once we get the elements which are there in a material, I mean to say, for example, in a steel, we have chromium, iron, so on. So once the customer gives the data sheet, according to that, we need to design the chemicals. Okay, so that you will get the finishing. So at the same time, the biggest thing that we are doing is finishing the lattice structures and so on. So chemicals can pass through the nook and corners of the complex surfaces, as well as part and parcel. It can also enter into the seizure zones of wherever it need to be finished. So that's how the chemical polishing is going to work as far in a better way. So next one is electrochemical polishing that you can see the video. So you can see anodic dissolution is taking place. This is how the so we have degreasing, rinsing, neutralizing, rinsing, electrochemical tank, hot rinsing, again normal rinsing. So effectively, if you see, we have 7 stations which are there apart from the rectifier. So these are all requirements are there for electrochemical workstation. So to get a perfect component out of the system. However, some people directly put into electrochemical station. That is a different story. So that you can see here, the as built is 9.763 is the micrometers is the workpiece surface roughness. That is finished by electrochemical polishing process to 0.619. That means at 0.62. Okay. So not only that, it also shines the surface. The third setup that we have is electrochemical plasma polishing. So here it is similar to your EDM plus ECM only, but you can do in bulk basically. So what is the advantage of this particular process is compared to electrochemical is here you don't use any chemicals basically. So you can use salts that you can procure, which are not harmful for the environment and so on. So you can use EDM plus ECM for I would say electrochemical plasma polishing for small workpiece to a large workpiece. Currently, the workpiece that we can handle is approximately like 15 centimeters to 20 centimeters. So you can see here how a rusted one, which is 3D printed earlier. So it is cleaned like this. The below one that you can see here is there is a tire mold basically. This is the tire mold part which we got it from one of the tire manufacturers. I guess it is from the MRF. So one of the segments, this is one of the segments that forms. So you can see whenever I want to remove the tire from the tire mold, if the surface roughness is very, very high, it is very difficult for you to remove that. So this is how one can do the electro polishing and electrochemical plasma polishing and so on. So we also have dry electrochemical polishing, and these are some of the subjected to the finishing process and so on. So finishing components that you can see on. Okay, regarding the biomedical, you can see here how electrochemical and electrochemical plasma polishing can polish. So as I was telling you during the early stages, it is not only about the finishing, but also people want the lustrous basically. Lustrous means you can see here as tabular heads, which are in spear shape. The surface roughness of both is approximately same. But whenever you go as a customer, you purchase the very shining one because that appeals to you. So because of that, some of the customers who comes to us says that we want shining nature so that no they can compete with the foreign components. So similarly, you can see at the bottom also. So we have 2 hip implants. I mean, say bone plates. One is approximately finished, but you can see this shininess under the things. So this increases the market value of the part. the OEM basically. Okay, so currently, for example, if they're selling at 20,000 or something, they may increase to 25 or 30. So it is just a matter of one process where you put for 7 to 8 minutes. So 7 to 8 minutes, if you are getting very, very good shining, so which enhances the profitability by another 5,000 to 10,000 rupees for him, it's obviously it is a good choice for him. Okay, so that's why. So now, till now, we have not seen the processes which are not utilized by abrasive flow machining or abrasives and other things. From here, you can see here mass finishing process where abrasives and components put together and rotate, and mass finishing will take place. So centrifugal iso finishing. The only thing that you have to be well aware of this is that the person showing here is showing clearly the abrasive particles, large size abrasive particles. Good. But which is not shown here is that, for example, if I want to see the good shining here, so first and foremost, either I have to go with electrochemical, or whenever going with centrifugal iso finishing or something, you try to put some chemical to it. Basically, that is not shown. So the people put already the chemical in the machining system and then they try to use. So these are the other mass finishing at Tirupati. We have drag finishing setup that you, those people who want to use the drag finishing, which is there on the right side, what you are seeing, which we have, and this is the robotic finishing. Please watch the videos. So what is the difference that you have noticed? So what is the difference that you have noticed is, if you see the bottom two pictures, in the one there is a spark, in another one there is no spark. That means that interaction forces, in the case one, it is doing the machining process. In case two, it is doing the finishing process. Okay, that's the only difference. So now we are moving to very complex scenario, that is finishing of internal features. So this is one of the project that we have with the Indo-German. So 6.8 codes project that we have regarding finishing of conformable cooling channels tied Tirupati. So for example, if I am making a die, whether it is aluminum die, casting die, or any other die, so 3D printing gives you a flexibility to the make the channels basically. So these channels where you cannot finish properly. So for example, this you have seen the balling effect where spherical balls are there. So they may struck. If the size of the path is 0.5 microns or something, it is nearly difficult for finishing and other things. So how do you finish these type of internal surfaces so that efficiency of the die will be improved? So these are some of the channels that you are looking at. So this is a system that IIT Tirupati, IIT Kanpur, and IIT Guwahati has developed, because as the technology that I learned at IIT Kanpur, then I implemented at IIT Guwahati. Now I'm commercializing at IIT Tirupati. So this is a overall system, and whenever you see here, this is about fixturing. Fixturing is to hold the component firmly and try to move the medium up across the surface to be finished. Third one is medium, and probability of getting the medium from outside India is very, very difficult. So that's why we make our own medium. So you can see the video, how the process works. So this is a video that you might have seen. There are 3 videos which you need to understand here. The first one, where the medium reciprocates across the surfaces. The second and third videos, where you can see here is that high viscous medium, how it works, and low viscous medium, how it works. So other advantage is if you can design the fixturing. This designing the fixturing such a way that all the blades you can do the finishing in a single go. That is the advantage of this one. Otherwise, normally what you have to do, you have to normally put there for some time, and then what you have to do is every blade, for example, if you go to an aerospace engine manufacturer, so what you can see is every time you need to make one blade to be polished basically. So that is the biggest problem. So you need to overcome that. For example, today I am fine, I can do proper polishing because it is a hand polishing process. So I am fine. Tomorrow, assume that I have a quarrel with wife, and I show mera anger on the blade, then it is gone. So let's start it. So that's why automation came to picture. So in this one also, you can make in a smart way the fixture design. If you can do, so you can push all the medium across the surface to be polished. Okay. So you can see here 1.75 to 0.4. Now I'm coming to the abrasive flow finishing medium, how it works. This looks very easy, and almost all this took my life of 2 to 3 years. So I learned a lot, definitely, and I am very thankful to my supervisor, Professor VK Jain. So who is like a god to me, definitely. So the sentence that normally he tells to me, I think you all know Professor VK Jain, is that so I don't differentiate between you and my children. That is a best compliment normally you normally a supervisor tell to a student. Oh, so it's always a thing. So he to take care of me like his son only. So I am very grateful to him, and I learned a lot. So this is the area that we developed. So normally, if you see here, what is the requirement? I have, for example, if you see the signs, why only viscoelastic medium? I have 2 things. One is continuous phase, another one is a discontinuous phase. So discontinuous phase is you have particles, blue particles, green particles, and so. So continuous phase, you have a ash color one. So blue particles means they are active abrasive particles because they are taking part in the finishing process. In the second one, we have a continuous phase where medium is there. So this is the very crucial for us. So for example, I am applying a shear force in this direction. So I am taking an element of viscoelastic element. So viscoelastic element means assume that I have a medium which I have viscous component as well as elastic component is there. Once I am pushing it from one direction, what will happen? So viscous component try to move in this direction of application of force, and elastic component tries to move in the perpendicular direction of the force. So how you take honey? Honey is a viscous material, and take into the hand, try to throw. What will happen? So it will move in the direction of application of force. So that's how it will do. If you take a pencil eraser for elastic, so you press it, what will happen? It will deform in perpendicular direction. So now, how do I club these two and I make with respect to abrasive particle? Okay, so when I am pushing in the fine ऊपर वाला figure में आप देखेंगे, so I have an abrasive particle and I am pushing in the linear direction or the tangential direction. What will happen? Viscous force try to move in this direction of application of force. Radial force will try to indent. So the composition of the material decide what is the axial force and axial velocity, radial force and radial velocity. Since radial velocity is much less because indentation velocity with respect to axial velocity, people don't consider it. So now the question here is, how do I remove the material. So depend on the compositions, I can design my radial component. I can dictate, in fact, the radial component and axial component and so on. So this is a medium that we have developed at IIT Tirupati. So one of the PhD who graduated is Sheikh. So not only him, we have many people who worked, including myself. As I said, no, I worked on this one. When first time I went to my supervisor in 2004, so Professor Sunilja was on the edge of completion of his thesis. So I thought Professor Sunilja developed a very good setup. I will also work on magnetorheological forensic process. I went to him and I said, sir, I also want to work. No, 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 no. You have to work on abrasive flow finishing. So medium, so in this situation where in that moment I felt not good. So I want, because my MRF was the latest technology at the time, abrasive flow finishing was. But he said to me, sir, I have a ARDV project where I am trying to get the medium from US. They are not supplying to us. So why don't you manufacture it? So then it's fine, sir. So as a PhD student, just one maximum what I can do, रूम में जाके रोना ही पड़ता है, तो कुछ नया चीज डेवलप करना है तो सो बट एनी हाउ सो ही सेज आई एम देयर, डोंट वरी, let us combinedly work and develop it. So that is the starting point of that. And when I joined in 2004 December under Professor V.K. Jain and Professor Ram Kumar. So if you can see here now currently what is our standard, almost all this is from 2004 onwards. Almost currently we are in 2025. That means that we are having in this field almost 20 plus years. If you tell what is your application, we can make our own semi-solid medium, which is smart enough. Why it is smart enough, I will come back when I'm going to talk in the later the stages. So this can deform with respect to atmospheric pressure, which is self-deformability. It can, if you are pulling very fast, that means the shear rates are very high, so it breaks into plastic piece. If you are pulling slowly, it comes like a bubble gum. So the flow and deformation properties are very, very complex enough. Because of that, what will happen? The science of flow and deformation you need to understand. That's why. So at the same time, whatever the medium that we are making is non-hazardous, eco-friendly, nothing. So what we try to do is we try to make this particular medium from the plants and other things. So commercial mediums are very, very expensive and importing charges are also very high. So it may ranges from 2 lakhs, 2.5 lakhs. For example, our medium is normally 1/10 of, so 10 times less. Okay, so we have some of the customers who approach us through the institute, we provide them. So these are the mediums and other things. As I said, it flows like a fluid. It behaves like elastic ball and breaks like a plastic piece and so on. So these are some of the things that normally the rheological part. So if you see at the bottom, there is a red one, which is called a fixed bottom plate. Why it is red color is that it has a heating element. So this is represented in. So if you want room temperature, you can give room temperature also. However, normally this ranges from -5 degrees to 220 degrees is the normal range of MCR 301, which I worked at IIT Kanpur. Currently, what I have at IIT Tirupati is MCR 302, which is the latest model, which has similar things like MCR 502 and other things. Okay, so the top plate is there, and in between I have medium. So bottom plate is fixed, in between medium is there, top plate is rotating. So now that you can see the practically what is going to do, this is the bottom plate that is there. In between I am putting a medium, semi-solid medium. On top of it I am having a top plate. So I am going to rotate it. Okay, so the flow and deformation studies we can understand. So now we can understand the shear stress versus shear rate. Shear rate is nothing but shear strain rates basically. if you consider all the graphs follow approximately same. So any one graph you can understand. So for example, if I am changing the shear rate, what is happening? You can see inside the graph, the physics is explained. I have polymer molecular chains. These polymer molecular chains are, when it start moving, it's start entangling and it start climbing each other, because of which what will happen is it will oppose the motion of a rotating plate which is on the top of the thing. Okay, so that's why the shear stress increases. But in certain time, what will happen? These polymer molecular chains will break into, and that is what you can see where the declining of the shear stress is seen. And whatever the broken chains are there, it will align in the direction of motion of the top plate. Because of that, what will happen is that you can see in the aligned direction. Now you can see the same graph, the signs of the graph can be explained vertically also. So if you draw a green line vertically, there is a green to the pink, it is decreasing. So now you see what is green. Green represents 7.5 plasticizer and pink represent 12.5 plasticizer. So 7.5 plasticizer is the thing, but so low quantity is there. And as you are increasing the plasticizer, you see here, I have polymer networks or polymer chains. So there is no plasticizer. Indirectly, what I mean to say that the distance between two polymer molecular chains is very less, because of which force of attraction between two polymer molecular chains is very high. As you start blending the low molecular weight materials, there is a possibility that this will go and sit in between the high polymer molecular weight materials and try to kick apart. That means that the distance between two polymer molecular chains will increase. As the distance between two polymer molecular chains gradually increases, what will happen? The force of attraction between two polymer molecular chains, or the bonding strength between two polymer molecular chains, will decrease. Because of that, what will happen? So what is the output of this one? I explained a lot of science behind it. So output is that I am taking a viscoelastic polymer where elastic properties are dominating, viscous properties are very less. However, my aim is to make viscoelastic material as per my requirement of viscous properties and elastic properties. So when I am taking a polymer, I don't have the amount of viscous properties in it. So I am imbibing the viscous properties to it as per my requirement. That is what I am doing. Okay, that is the meaning of what is this particular graph is all about. So once you are talking about viscous and elastic and elastic and viscous and viscous and elastic, you should know what is viscous and elastic properties. So this is going to be measured. So for example, if you see the top graph, A to B is viscoelasticity and B to C is viscoelastic recovery. That means that I can measure visco plus elastic, then subtract the elastic. Now the question is, you are checking with respect to the time the creep recovery. That means that you are measuring some strain values. So the question mark is, how do you do the creep recovery test? What you do the creep recovery test? You try to give either stress and observe the strain, or either you give strain, observe the stress. So now the $1 million question to ask is here is, what is the stress that I have to apply? So for that, the bottom curve is there, where I'm choosing a shear stress ramping and understanding the storage modulus. When I'm understanding the storage modulus, there is no change in storage modulus as though I'm changing the shear stress. That means that my polymer molecular chains are intact. After that, what will happen? These chains are stretching and some chains are breaking. That means that my polymer molecular chains are in a not in a normal state. That means whenever I want to measure the viscous and elastic characteristics of any polymer, I need to choose the right location of this one, which is called linear viscoelastic range. That means that where my polymer molecular chains are at original strength. This particular thing, I took 100 pascals and I put 100 pascals shear stress and observe the shear grip compliance. So now I am putting 100 and I'm holding for 500 seconds and releasing. So what will happening is A to B is viscoelastic and B to C is elastic recovery. Because of that, I can measure what is viscous and elastic. For every medium, we can understand what is the viscous component, what is elastic component, and so on. Once you understand the viscous component and elastic component, what is the range of viscous component normally good for the finishing applications? So for that, we have varied a set of viscous and elastic components, and we have understood that at a 55 percentage of viscous component, that means that 45% of elastic component, it is giving better flowability, better abradability, better properties of all the things. Okay, so that's why the finishing is given self-deformability and so on. So now you made the medium, and this medium you need to compare with respect to what are the other mediums across the globe available or people. So for that purpose, we have checked with respect to various mediums that are available across the globe by the researchers and so on. So now we move on to the capability checking of this particular medium for finishing of the complex surfaces in additive manufacturing. The one of the biggest thing in additive manufacturing is Markforged. Markforged work on a fused filament process where metal particles will be there and polymer will be there, and polymer will help to bind the metal particles. Then you do sintering, so the polymer goes out and remains the metal component. So but basically the surface uh, roughness will be very, very high. So that's, for example, if you see here, the surface roughness is 7.62, the perpendicular parallel direction and perpendicular direction is 5.03. So from there, if you do the finishing action, normally if you see here, this is the initial and this is the final surface. So you cannot remove the manufacturing defects definitely, because it is a fused deposition modeling where line by line or track by track it will be do. That may not be the complete solution. So the complete solution, is many other customers also there. So SLM component, selective laser melting, selective laser sintering, laser powder bed fusion. These are all the names are approximately same. So this is the initial, you can see here. After 15 cycles, after 75 cycles of a bristle flow finishing, how we are converting. After 255 cycles, 350 and 375 cycle, you can see a very, very good images or surface finish that is achieved basically. Okay, so now you can see here the initial surface roughness was 7.4 microns, and after finishing, so if you see here, we have got the surface finish about 0.49, which is nothing but around 0.5 or something. Okay, so 1 minute, I'm just taking it. Okay, so this is the one, and so see what we have done is we have converted this particular surface into this particular surface. So as an engineer, very rough surface on a flat surface. Once why you try to do on a flat surface, it is easy to measure, it is easy to understand, it is easy to do all type of characterizations. So first and foremost, we try to do like this. Then the people can go for commercial components. Once you have wheat flour, you can make chapati, parota, puri, dosa, or pakodi. क्या बनाना है बना लीजिए. So what the thing is that you should have the recipe for it. So that is a science. So and these are the some of the large components, and this is the some of the these components also that you can see here. And with our collaborators and other people, we have done the estabular heads and so on. As I was saying, for the drug eluting stent and other things, when you do a laser micromachining, what will happen? Laser micromachining follows a Gaussian beam distribution. This Gaussian beam distribution make a hole at the center. When it comes to the edges, it melts and resolidifies, which makes the recast layer. So the recast layer look like this. Okay. So when you want to make drug eluting stent, this surface is a hindrance. So the first problem is it cannot allow the amount of drug has to be eluted. Second, metallochemistry of this one will change. The third and foremost important one is these recast layers, which are not part of the finishing, I mean, say, parent material, may dislodge from the place and goes and kills the patient. So these are the problems. We have recently closed this project for finishing, micro machining and finishing of these implants. So I said it is a smart fluid. Why it's a smart fluid is with respect to the temperature, we can improve or increase or decrease our medium viscosity basically. So assume that person has purchased like a 2 lakhs Pascal seconds medium, for example, for large structures that they want to finish. Later, they want to use it for smaller sizes. Well, you can do because if you have a temperature controlling unit, you can put on the medium cylinder so that no viscosity will change, so that you can smartly manipulate or modify your polymer molecular chains interaction. Because when you give the temperature, what will happen? So the energy goes into the polymer networks and they start vibrating and move apart. Because of that, what will happen is the viscosity of the medium will come down. So now I can, so once it come down, now we can see how the finishing, it is not only about lasers, you can also use for microEDM applications also. This is the same thing that you can see here. So drug eluting stent and so on. One can also apply for fuel injector nozzles and for deburring applications and so on. So why it is a smart machine that we have developed? As I said, Rome is not built in a day. So started the career in 1996-97 by Professor V.K. Jain. This abrasive flow finishing, which is again established by a person from Gwalior, who is none other than Sunil Jha, along with Vijay Kumar Gorana and other people in 1996, which I am not part of that particular system. But I worked with them because the plates are very, very heavy and safety factor was very, very high and so on. So whenever they want to do experiments, at least 2-3 people will be there to lift the plates and so on. So later we designed as per our requirement and the less safety factor, which is required. So ANSI softwares and other softwares are there. So we designed. Then we have incorporated some of the motions for dynamic finishing and other things. 2019-20, we have made a smart machine, which is HMI and a thing that you can show here. This is anatomical structure of our system and how system look like this. As I said, machine understanding is more important. Developing an HMI, developing the controllers for it, whether I am a mechanical engineer or not a mechanical engineer, doesn't matter. You can collaborate and you can do. That is what I did. I am not a electronics guy. So that's why I took the help of my, you can say my brother or my mentor or my senior or something, Professor Sunil Jha, he has a lot of knowledge on mechatronics and other things. So as a part of this, it is a combined project between IIT Tirupati and IIT Delhi. So we combinedly developed the complete system. In my view, the most important thing is the process. If I have an innovative process, you can develop any smart thing to it. Subjected to, you need to explain to the electronics guy what is your requirement is all about. However, in the case of Professor Junida, he is also know about abrasive flow finishing, so I need not to explain. So, my thing is science of the process is most important. If you know the science of the process, once you develop the basic mechanical structure, developing a smart structure with HMI, human machine interfacing, by putting some of the PLC controls, some of the sensors and so on, it is always good. This has a temperature sensors on the medium cylinders. Whenever the medium cylinder gets heated up, there's a cooling channels and other things. So that what will happen? The medium temperature remain approximately same, like 25 degrees plus or minus 1 degree, so that the viscosity levels will be approximately same throughout the experiments. Okay, so this is a side view and front view again. You can see here how lot of details are given and side view control panel, and these are all run by a background which is called hydraulic power pack. So our hydraulic power pack is from Parker. So this is another thing which we make the smart system. Okay, so technology transfer and so we have also given similar things to CMTI Bangalore, which I have not shown here. So these are the equipments. I have completed my lecture. So these are the equipments that we have at IIT Tirupati. So let me list. We have metal 3D printing, laser powder bed fusion, which we have UASM 290 from Germany, WAM, Franiosis, wire architive manufacturing, twin wire architive manufacturing, which we have. And we have ceramic 3D printer, we have polymer 3D printer, we have Stratasys 3D printer in polymers, and bamboo labs and other things. Post finishing equipments, we have blasting, sintering, and so on. Finishing 3D surface profilometer from Bruker is there. YREDM from Agile Charmilis is there. DMG Mori milling and lathe is there. High speed camera and IR camera is there. Micro nano indenter and XRD powder and solid CMM out of furnace tester. PVD, we have RF magnet sputtering and DC pulse sputtering. Single target as well as multi-target. We have tribometer where we have rotary, reciprocating and so on. So we also have 3D filaments making, which I have not shown here. So those people who want to make their own filaments of customized filaments, you can tell us, can fabricate and we can provide you. So micro machining center, which I have shown you already. Laser micro machining center is a separate one that we have, which cost us around another 2 crores. EDM, FESCM with the EBSD, EDS, lithography, and so on. Atomic force microscopy, PP. These are the equipment which are coming. PPMS is one of the costliest machine that we are going to procure. That is physical property measurement system. The starting price of the system is very, very expensive, and it goes up to like 20 crores or something. XPS, again, it is 6 crores equipment. HRTM is the second biggest equipment that we are looking at is high resolution transmission electron microscopy. LIPS, we have already laser induced plasma breakdown plasma spectroscopy, DSC, TGA, DTA, these are all there. Differential scanning, electron scanning, calorimeter, and thermogravity analysis and other things. Bioincubator, in vitro, in vivo, friction state processing, which we are procuring it. So we are open for summer interns who can come for long durations, preferably like 6 months and other things, postdocs and BTech project, MTech project, and PhD project. If you want to do partial works at IIT Tirupati, you can come and you can do, subjected to terms and conditions of the institute and so on. So I'm very grateful to Elsewhere. I'm also associate editor for Journal of Manufacturing Process Elsewhere, which is a Q1 journal and impact factor about 6.1. I urge the people to submit the papers. Our acceptance ratio is very, very small. Sorry for that. Our acceptance ratio is only, I think, 7 to 8%. So if your science is very good, innovative science, don't say that somebody has done on a stainless steel, I will do on a copper, I will do on titanium or something. That is not what we expect from you. And a new science that is required. And don't think that if the paper is rejected, Ravi Shankar is not rejecting. See, Ravi Shankar is an associate editor only. I am associate editor. I am just a postman. So it is my responsibility to respect my reviewer comments. So depend on my reviewer comments whether it is accepted for further movement into the reviewers or rejected at the early stages, taken care by me. Okay. So however, all the reviewers will be under our place, whom we always send to the right people. So you need to choose your keywords accordingly. So many people write just casually the keywords. Don't take casually. So if your work is tribology, use tribology. If your work is micro machining, use the micro machining. So depend on the keywords, we get the suggestions on the screen whom we have to allocate this paper. Okay, it is not that, oh, something you take very seriously the paper. When you come to the keywords, you made a mistake, then your complete paper will be a problem. So anyhow, if somebody want more information, they can ask me the later also. And I am very grateful to all the funding agencies. I started my career at IIT Guwahati with 5 lakhs. All the long journeys will start with a single step. So Baba Atomic Research Center about 23, DST about nearly 1 crore, where that machine we have developed, DRDO about 75. Then we got a big project from IT, Department of Electronics and Information Technology. Now it is called MITI, Ministry of Electronics and Information Technology, about 60 crores. Imprint about 3 plus 3, 6 crores from IIT Kanpur and ISC Bangalore. These are the projects that I have completed already. The SCRB 45 lakhs and BIRAC, which you have seen the drug eluting stent about 41 nearly, and SCRB CRG that I have 32. And then we have a project from IGSTC about 6.8 crores. So these are the recent projects which we have. Respond is about 32, DST about 61. Small projects, IKS, TAR. So those people who are interested to apply for TAR, this is for the private engineering faculty who want to pursue the research at IIT level or any premier institute level. You will get almost all 20 or something. I have one person from Amity University in Noida. So ISRF is not for you. ISRF is for the countries who are outside and comes. So one of the person came from Burma, and our consultancy, we have DRDL consultancy and power grid. Apart from it, we have a very big project. I'm thankful for another 120 crores, where one of the vertical is precision technologies and positioning in that one precision manufacturing. This is one side of the coin, and other side of the coin, we have students. I am just a front face out of it. Okay. These are the students who work. This is my IIT Guwahati group. I have to take my photograph with respect to my Tirupati group. Soon I will take. Okay. With this, I am very grateful to all the people who are listening to my lecture, and organizers, Manoj ji, Vinit ji, Snehika ji, and other people. And if you have any queries, suggestions, comments, I am ready to take up. Thank you. Thank you all.
Thank you, sir. So this is in question and answer time. Participants, if you have any question, then please ask. Dear participants, you may ask the questions now. This is question and answer time. I think there is no question, so we will conclude this session. Thank you, sir. Now I invite Organizing Secretary, Mr. Vinit Raj Singh Kushwaha, to propose vote of thanks.
Good evening, everyone. I am Vinit Raj Singh Kushwaha, Organizing Secretary, on behalf of the Organizing Committee of this one-week faculty development program on recent advances and applications of manufacturing in Industry 4.0. Extend my heartfelt thanks to the eminent keynote speaker, Dr. Mamila Ravi Shankar, Professor IIT Tirupati, for sharing his deep knowledge on smart abrasive flow finishing system to finish complex additive manufactured features with us. The way he explained the topic was extraordinary. Really, sir, I liked it.
Thank you,
He's spotlighted on the process of developing sophisticated human-machine interface and various machines for it. It will really make a strong impact on our knowledge and career growth. A big thank goes to the participant also for listening it and making it enthusiastic. Thank you all once again.
Thank you, sir. And thank you, Ravi Shankar, sir.
Thank you, sir.
Thank you, Ji, all the people. Yeah, thank you.
Fine.
Yeah. So hope I am on time, I think.
Yes, sir.
Yes, sir.
Yeah, yeah. Thank you. Thank you. Okay. Thank you.
So, dear participant, today's feedback link is very much important, which will be given at the end of the program in chat box. Please fill and submit it on time. It is requested to all, please stay online. The next session will be started soon. Sir has joined. Navneet, sir.
A very good evening.
Good evening,
sir.
good evening, sir.
Good evening, Vineet, Manoj.
Good
Good
evening,
evening,
sir.
Suneka ji. Good evening.
Good evening, sir, and welcome. Welcome, sir.
Thank you. Thank you for inviting me for this session. Thank you so much.
Thanks to you, sir, for accepting our invitation.
Really.
I cannot say no to Mr. Manoj.
Okay. So we will proceed for the next session.
Thank you.
Good
So,
evening.
shall I start, Dr. Suneka, or you would like to
Sir, I would
set
like
the
to
context?
introduce. I would like to introduce you. So, good evening, everyone present over here. So now we will proceed for our 13th session. The session will be followed by valedictory session, where participants can give feedback by making camera on. Feedback of last session is very much important for attendance. Now, I invite Professor Navneet Singh Rajput, working as Vice President, Asenso Tires, to deliver his talk on automation and robotics in manufacturing. But before his talk, I would like to take the privilege to introduce our next resource person, Mr. Navneet Singh. Sir has 25 years of experience in automobile industry. He is an expert of commercial vehicle industry, having vast knowledge of business in India, South Asia, Asian Russia, and CIS and African continent. Mr. Navneet started his career journey with Escort Limited in year 2000 as assistant manager. In the year 2001, Navneet joined Tata Motors Limited in 2001 and worked in multiple departments for 23 years. He has vast knowledge of automotive CV industry and worked in domestic and international market. Sir is currently working as Vice President Sales in Asenso Tires and responsible for company operation in Africa, Asia Pacific, Australia, and Indian subcontinent. Now it's time to hear from our resource person, Mr. Navneet Singh Rajput. It's over to you, sir.
So, thank you so much, Sneka, for introducing me.
Thank you.
And I was having discussion with the Dr. Manoj, and I was telling him that my domain is completely different from the manufacturing, because I'm sure that by now many sessions would have covered the manufacturing aspects of the Industry 4.0. And I just thought that I will bring another, let's say, angle to Industry 4.0, that how this is transforming the business beyond manufacturing also. And of course, I mean, manufacturing is a part and parcel of it. But this, the evolution of the Industry 4.0 has given such a huge opportunities in multiple areas. In my session, it would be less about manufacturing, but it would be more about the kind of opportunities the Industry 4.0 is throwing. And I'll also be covering that how the automotive industry is, kind of evolving with this Industry 4.0. And if any questions, you can ask within the session also, and maybe after the session, like with the previous professor, you can ask me towards the end. Snehika, I'm going to share my presentation. Just let me know once it is visible.
Okay. It is clear, sir. Visible.
Clear. Thank you. And I think I'll just to keep the bandwidth safe, I'll go on. Cool. Thank you. Okay. So I think by now everybody would have understood the evolution of the industry. I just thought that maybe I will also set a context in this session. Is that we all know that the industrial revolution started in 1780 when the steam machines got invented, and then a lot of mechanization started. And since then, that was called the Industry 1.0. And once the electrical energy was available, and that made it possible to go for the mass production. You can have assembly line, the conveyors, and that has kind of given a different twist. And Industry 2.0 helped, let's say, in that era to go for the economies of scale, which was not available when the Industry 1.0 was there. And 1970s, or let's say, I mean, it started in 1969, but 1970s, we know that the NC, CNC, the chip, the early phase of the computerization started. And some form of even the robotics also started. Maybe it has come late in India, but in the other parts of the world, especially if you know about the Toyota story, and if you have heard about the German story, then you would have known that in 1970s, 80s itself, they have gone much ahead in terms of the automations in their manufacturing, in their factories, and a lot of integration of electronics and informatics started there. Industry 4.0 is this is what our topic is also. I think this is something which started in 2011. I would say the pillar is the internet. When the internet maturity happened, then a lot of elements of the manufacturing, it has given the opportunity to couple it with the cyberspace, and that has kind of transformed the entire ecosystem. I will not just say the manufacturing itself. So then you started having the industrial internet of the things. The difference between the cyberspaces and the physical spaces started contracting. Cloud has given an opportunity where the software as a service has transformed it completely. And of course, the robotics, which is far better than what you used to have as a robotic arm or something. The mechanization, these days we talk about, like I give you from my context, since I'm coming from the automobile industry. Whenever we set up a plant, we speak about how much is the automation percentage. I'm sure that as a faculty, as a student, you would be aware of that. And in our terminology, we speak that our plant is 80% automated, 90% automated, 95% automated. And all this has become possible with the introduction of the Industry 4.0. I just thought that I will give you a glimpse of what is going to happen next also. And the next is just give me a sec. I'll just bring it down. Yeah. I don't know whether you are aware or not aware. The talk towards Industry 5.0 is already started, and that is largely would be around the sustainability, the circular economy, the resilience. It would be how the industry should, with the so much of technology available, how can you use this technology to make it more meaningful for the planet, more meaningful for the people, more meaningful for the sustainability. And that is why the buzz right now is that the circular economy should be the way forward when it comes to the industry. So whatever I am consuming, I should be able to take it back. And that is why you would see that a lot of policy formations are happening worldwide, including India, where you would have it about a scrap policy. After the use of 10 years of the automobile or 15 years of your car, it should get scrapped, and the scrap should come back to the industries in the form of the metal, plastic, wiring, whatever it is. And hence, you should stop using the fresh material less, so that the mining can go down, because ultimately at the end of the day, the mining is something which is damaging the planet, and hence the need for the circular economy. So already the talk towards Industry 5.0, it is still in the early phase, but that talk is already started worldwide. Of course, the Europe takes the lead in this case also. The Europe is taking the lead, and they are already working in the directions where they want not just the manufacturing or the industry, but also the, the governments, multiple other facets of the, the human life where it could be implemented, especially when success of the Industry 4.0, which looks like is going in the right direction. So in a nutshell, basically what we are talking about here is Industry 4.0, which is the intelligent interconnection of the machines and processes in the industry with the help of the information and communication technology, because that will help you to get the better output, the better efficiency. I mean, that is what I'm covering in my next line is, so it basically involves the integration of various technologies, particularly the Internet of Things technologies into existing technologies. So you already have a plant, and now you have the revolution which is happening in the digital space, and then you merge both the things. So much of machines, mechanizations, automation is already available. Now with this evolving digitization, if you marry both, then it's going to do the wonders as far as the manufacturing sectors, production, industrial, or even the uh, 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 I will say even the, from my perspective, even the sales and marketing is also concerned. I mean, it's going beyond that, and I will cover that, and I will show you that how it is changing the face of the business going forward, and what probably you are not seeing today, maybe in another 3 years or 5 years, you will start seeing that. So point here I'm trying to draw is that the integration is actually opening up new possibilities, covering the manufacturing, industry, productivity, and efficiency, and also it is becoming the backbone of multiple new businesses, which is fueling the entrepreneurship right now. And I mean, I just give you one example, and from that perspective also, while the idea was, dropped, but I don't know how many of you know that mobile manufacturing company called Apple was planning to build an autonomous car. So thinking about, somebody who is making the iPad and, laptops and mobile, and then thinking about making a car and getting into that, from where this idea is generated, because of the technology which became available after the evolution of the Industry 4.0. Because now, you don't have to be a conventional player. You can actually get into in a different field if you have expertise in this domain. And even for the companies which is currently, let's call it a conventional companies like I represent here, I have worked in Escorts, I have worked in Tata Motors, I'm working with a tire company called Ascenso Tires right now. It has even allowed conventional companies also to find the new sources of revenues, and I will cover that in my subsequent slides, as how this is, kind of helping the organization at an overall level, just not at a one domain, which is manufacturing. So what basically we are talking about here is the main enablers, which is, driving the Industry 4.0 revolution. I will say it's basically the industrial Internet of Things, the robotics, the cloud, the big data. I'm sure that especially in the academia and the school and the colleges, I mean, this is a big buzz, because big data and artificial intelligence is something which is, fueling the curiosity everywhere, from a household to the industries, to the schools, to the colleges. Even my kids are talking about artificial intelligence these days. Virtual and augmented reality, it was there from quite some time, but not getting to the right use. But I think now going forward with this big data and artificial intelligence, and virtual and augmented reality can actually create a huge impact when it comes to the industry and the other streams of the businesses. Simulation, cybersecurity, the more, the automations happen, the more digitization happens, the cybersecurity is going to be a major aspect of the same. A lot of integrations is happening with the existing system with the digitizations. And like I mentioned, the CPS is nothing but a cyber and physical system integration, which is happening. The major principle of the Industry 4.0 revolution is basically the interoperability, because the seamless communication is and the integration of the multiple components of the manufacturing process and the ecosystems are happening right now. Virtualization, I mean, it's like I mentioned, VR and AR are fueling the virtualization, and I will cover that in my subsequent slide also. A lot of decentralization. Earlier, the decisions were made. I mean, if you remember that, if you go back to any manufacturing setup few years back, let's say 15, 20 years back, you used to have a common command centers. But now you will see with the more mechanization and the digitizations, you will have multiple command systems responsible for taking the call then and there only, and not waiting for the, from the centralized command. And so it's helping in terms of the productivity and the efficiency. One of the major, you know, uh, aspect of this is that the real-time capability, because with the integration of the physical and the cyberspace, the data is available on real-time basis. So you don't have to wait. I mean, I remember that when I used to go to my factories, today's production plan is this much. By the evening, we have missed the production plan because of the breakdown, or because of, sometimes, the other reasons. And then we used to study that why it has happened, and next day take the course correction. But these days that's not required, because the real-time data is available, and every time you have your prediction that how much I'm going to produce today, how many cars I'm going to assemble today, how many trucks how many axles I'm going to bring it here. So data is available real time. So the integration is seamlessly happening. Of course, the service orientations, because a lot of physical processes are getting digitized, and which is giving the space for the service industries also to pitch in, and modularity. So, I mean, I just give you one example is what we are doing right now. In Tata Motors, we have created one platform and now developing multiple automobiles out of it. So this was not available earlier. And just think about it, that if you have to, let's say if you have to bring 5 models or the 10 models and 10, 20 vehicles, you will have to work on the 20 vehicles simultaneously, and it's a cost and money. With this, the modularity is giving you the opportunity where you're working on one model, and then you know that I can make a hatchback out of it, I can make a sit-down out of it, I will use this same platform to make and and you would probably be seeing the same when you are seeing it right now, the cars which is coming these days in Indian market. So a modularity is giving a huge opportunity, and that has happened only because of this, because the 4.0 has allowed people to play with the data, and one set of data is helping them to now extrapolate as that how they can, create multiple platform out of the single platform. Some of the advantages, I'm sure that this would have been covered, but I will also cover as part of my presentation, is that the mass customization. I mean, I just give you one example, is that today if you go to a Tata Motors website, you can actually customize your truck, which truck you want to buy. So I want to buy a truck which should have there are 3 options of the engine, there are 2 options of the axle, there are 2 options of the gearbox, there are options for the how long the chassis could be. So this is possible only because of this industry 4.0. So it is helping the businesses and the organization to go for the mass customization. And like we always say that customer is a king, and the more you please the customers, the more loyal the customer would be, and that is what is required in the business. And this is facilitating the converting the mass production also into a personalized manufacturing, which is increasing the customer engagement and loyalty towards your brand, towards your products. Digital operations, I mean, I think COVID is the biggest example of the same. The country, I mean, we have seen the 2 waves, the country was shut down, but I'm sure that all of you know that the industries are working. And that could happen only because of the digital operations. So that was not possible earlier. So that helped the industries to, even in the face of the disruptions, the remote control was available and the business continuity was there. I already covered the sustainability aspects, but I'll just cover once again. Is since the data is available on real-time basis, the resource optimization has improved, which is helping the waste reduction, the energy efficiency operations, and even to the extent where the corporate social responsibility (CSR) objectives are there. Like for example, I work in a company called Essence right now. I joined this company some 2 months back. 50% of our energy is either wind energy or the non-renewable sources or a solar energy. And we take pride in it because that is what our goal in sustainability. So why this is happening, we know that on daily basis, we know that, what is our source of energy, and then we can, kind of take that. And that helps us to improve our, meet our sustainability goals also. The adoption of the Industry 4.0 provides a decisive competitive edge. It's, quality, when you have the data available and the digitization available, then your agility improves. And once your agility improves, you can actually deliver better quality products. And if you deliver better quality products, it will of course ensure your growth and market dominance. With the introduction of the AI and automation, the productivity and the operation efficiency in manufacturing is going smoothly, and more organizations are now going in this direction. Quality control with the real-time analytics available. I give you one example, like all your electric vehicles which is running in the country has a common command center. So I give you one example that how this is functioning and working in the industry is there is a vehicle called Tata Ace EV. I'm sure that many of you would be aware of that. And our people sitting in a Pune plant, all these vehicles are connected vehicles. So our people sitting, we have a common command center in Pune, and our people can actually see that in which vehicle, which is operating at which GPS location, the battery is heating up. And what they will do is that they just have to make one call in that area to the dealer and telling him that this vehicle may go for a maintenance. And please call the gentleman and tell him to bring the vehicle to the nearest service center. So think about then, the preventive maintenance is so much possible. I think this is the predictive maintenance and preventive maintenance, which is the last point. So both quality, it is throwing data, which is helping us to take better decisions and improve our existing product, and also the predict the maintenance, because more the connected vehicles are there in the system, the data is populating, and there are command centers in which is continuously monitoring the data and analyzing the health of the vehicle. And I'm just giving you this example from a vehicle perspective. Just think about the same from a a manufacturing setup perspective also. And Industry 4.0, it's empowered the adaptability and agility, because like I mentioned in my previous slide also, the lot of decentralized decision making is possible because the real-time adjustments you can do, which will give you the competitiveness. Okay, this is a very different slide, and I just thought that I will put it because this is what the challenge which we face when we think about a change. This is where the problem starts, and this starts everywhere, including the industry also, in any company for that matter, is because whenever there is a change, we are sitting in our comfort zone. Why do we need to do that? And the whenever new technology, any disruption, new innovation comes, the organizations and the industries are sitting in comfort zone. They don't want to change themselves, but that is the need of the time. So the next reaction is that, why should I do that? there's a lot of resistance. There's a lot of cost benefit analysis done. The discussion on the relevance of adopting the technology happens. So I am trying to tell you is that what happens behind what you see in the industries whenever you bring a new system, or let's say in this case the 4.0, and how we face this, and then the learning phase starts, where we have to be more transparent. We do a lot of trainings, we do a lot of communication, and then only it brings acceptance of. In industry, the automation and mechanization always, there's a fear of joblessness or job loss, whatever you call it. And hence there is always this angle which comes, and hence we have to go through this. And then the communication, the trainings happen, the acceptance is built. And once that is established, people start reaping the benefits of the same, and they see that, this is helping them. It is simplifying the processes, the systems, the manufacturing, manufacturing process, the lines and everything, and standardizing. And at the same time, as I mentioned, that it also gives you opportunity to enter into new business. So some of the things which I thought I will cover from the automobile perspective is how this industry 4.0 has thrown the opportunity in automobile industry. And these are some of the topics which I will cover here, which is basically the telematics, electrification. I think so many projects are currently going on, even in colleges and universities, where the battery electric vehicles and hybrid technologies are, is being worked upon. Autonomous car, software-defined vehicles, connected vehicles, and I'll cover this from a different angle, and then how the AR, VR is actually changing the entire philosophy of the showrooms, and mobility as a service. All these things were, I mean, probably you could not have imagined had Industry 4.0 not happened. The Industry 4.0 has allowed all these, changes happen, which is actually changing the, let's say, the era of the automotive industry. And I don't know that how the conventional player will catch up on this, because the way that all of you guys are aware of the Tesla story or the BYD story. And if you're not, these two players, the Tesla and the BYD, which is a Chinese company, is ruling the electric vehicle game worldwide, and even going towards the autonomous and software-defined vehicles. Okay, so some points I will cover it here, and so these are the telematics, and I hope that I don't know whether I can ask this, Manoj. I mean, are we aware that what is telematics? I can ask the audience.
Yeah, sure.
So any professor, any student, if anybody would like to speak. Okay, so telematics is nothing but this is, let's say, it's a chip in your truck. I mean, I just wrote the truck because, of course, the car is already there. So you have your chip in which you insert one SIM, and now your vehicle is connected. And there is a software which is installed in your vehicle, which is connecting your vehicle to the common command center. So it's basically the software which takes care or which shows the health of your vehicle, and it shows a dashboard in which you can actually see where your vehicle is, what is the fuel level, what is the mileage, what is the tire pressure. So you can actually see, I'm giving this from a concept of a truck, because trucks are the backbone of the country and they run all over the world and all over the country. And imagine you are a businessman having 200 trucks, and on your fingertips, you know that which vehicle of mine is currently idle, which vehicle of mine is currently not even started, which vehicle of mine is running which part of the country, which vehicle is giving what kind of mileage, which vehicle is covering the distance right now. So I mean, this is what it gives a owner a complete dashboard of the performance of the vehicle, and that is why the people. So do you have I mean, just a software you can see on your laptop, and at the same time you have got a uh, apps on which you can, at any given point of time, you just open the app and you start seeing the, where your fleet is, what's happening with the fleet, what is the mileage and other things. Now think about the next step. So these are like Tata Motors telematics is called Fleetage. I shall call it a My iShare. Ashok Leyland call it an iAlert. And I have written one line, evolving into a marketplace. Marketplace means, just imagine that if this app is throwing so many people or so many customers are connected to this app, and if I convert this app in which I will bring insurance also, I will bring oil selling companies also, I will bring tire companies also, I will bring spare part companies also. Look at the opportunity it is throwing right now. So from look at from a conventional perspective, I manufactured car or I manufactured truck, I sold it, somebody is bringing it in the show the workshops, I am taking care of the service of the truck or the car, and I'm selling the spare parts. Now look at from this perspective. Apart from that, I have converted my software or my app into a complete marketplace where I am bringing the more business opportunities just because I have this technology available with me, which was not the case earlier. So so like I mentioned in the beginning, is that the 4.0 has allowed the businesses or the companies to think beyond their conventional means of the business. So such is the impact of the industry 4.0, where this is bringing the new stream of revenues, new stream of profitability. Electrifications, I mean, there was a point when the Samsung wanted to make the car. Who would have thought that, they have dropped the idea now, because with the AI now they are focusing only on the chip. Initially, even they thought that we will enter into a car business. Why they thought about a car business? Because the business from a typical, ICE vehicle, internal combustion engine business, and now you don't need the entire driveline. The electric motor and battery is sufficient to run the vehicles. So many, I mean, it's actually threatening the conventional players. I don't know how many of you follow it, but if you read the companies like Nissan, Honda, they're in bad shape. You go to Renault, they're in bad shape. Citroen. There's so many companies who have not been, and I'm taking worldwide names because the Indian companies fortunately has caught up in this game. But there are many conventional companies worldwide who were into the automobile business, they have not thought about it and have not started early. And now they're I mean, their sales are depleting, their revenues are depleting, their profitability is gone for a toss, and their position is getting threatened. So this has allowed the new players to kind of enter into automobile industry. And what's it giving? It's what it is doing. It's creating jobs, throwing newer opportunities. In India itself, we have got now more than 500 setups who are working on the EV technology. And let me tell you, in the recent Bharat Automobile Expo, which happened in the Delhi in the month of January, so many new players has come out with their trucks and cars. And probably people that doesn't know their name: Eka Mobility, Euler, IP technology. So many new companies are getting into this domain, and it's only going to go in that direction. This is, I mean, another software-defined vehicles and autonomous cars, again, a byproduct of Industry 4.0. Software-defined vehicles is nothing but, these are the vehicles which use FOTA. FOTA is nothing, basically, the software-defined, it basically enables the connectivity and automation and personalization. And over the life cycle of the vehicle, you can keep changing the software and keep personalizing your vehicles, and do with the vehicle. So there are vehicles whose gates will open with the sound and with the music and also. So, I mean, that's what it is happening right now. So, and of course, the autonomous vehicle, probably we in India, we are lacking in it, but worldwide, especially in the US, has taken a major lead, especially California has taken a major lead, where, the autonomous vehicles are, and followed by the China, let's say in this case, where the autonomous cars are becoming the reality. This might be, I don't know how many of you are aware of this, but this might be very interesting because this is something which we, let me say, in India, in our हमारी भाषा में जब बोलते हैं ना smart city. So people sometimes say, I mean, smart city, what does it mean? I mean, this is what it means. This is what it means when we talk about the smart city. It's basically we are talking about a city which is complete. All facets of that city is connected through with each other through the technology. So if from a vehicle perspective, it's basically the vehicle to vehicle, the vehicle to infrastructure, the vehicle to pedestrian, and vehicle to everything. So this is what it's evolving, which is going to be the cities of the future. And just imagine a vehicle to vehicle interconnected. So you have got vehicles, which is, let's say, multiple vehicles are running on the highway or on the city, and all vehicles are interconnected. You know that a lane departure could be fatal. You know that when this person is slowing down, you know that this person is going to push the brake. If there is any panic, there is any accident, just imagine the scenario where the vehicles are all interconnected, and this is happening. The work is already going on. The vehicle to infrastructure, I mean, this is where the vehicles are actually communicating with the traffic lights, the weather conditions, the road conditions, the municipal corporation softwares. So they are basically on a real-time basis talking to the infrastructure and receiving the data, and it is actually helping the city to manage vehicle to pedestrian. So it's largely to take care of the safety of the pedestrian, because the pedestrian safety is paramount in this case. And if the pedestrian and the vehicle both are connected, then you can think about that whether there is a zebra crossing, there are footpaths, then if there is a connectivity, the safety could be taken care of. And combination of all this is called V2X, which is basically vehicle to everything. So all type of connectivity, when you connect, that becomes a vehicle to everything. So driver can receive updated vehicle data, which helps them to improve the driving experience also. At the same time, takes care of the other aspects, whether it is just not the safety of his experience, but the safety of the others also. So that's what is happening with this smart, vehicle, which we call out a smart. When we talk about smart, so in terms of smart city, we're talking about, the civic services are integrated with the road infrastructure. The road infrastructure is integrated with the transport infrastructure. So when all parts of the city will start talking to each other, that city can convert into a smart city. I'm sure that everybody, when wants to buy a car, goes to the showroom. But actually, the trend is changing now, because showrooms are brick and mortar shops, big shops, and these are the Taj Mahals created, where the people can come. The intention is to come and experience, touch, feel, see interior, have sales stock. But I think the Mercedes has taken a lead, where they have decided that barring few key showrooms, they are going to move completely to the virtual showroom. And how is this possible? Of course, the industry, it's a byproduct of the 4.0. And Mercedes has decided that because their showrooms are very costly because of the look and feel, and the return on investment is a angle into it. Just imagine, so they are now moving into the virtual showroom space where, with the help of the AR and VR, at your home, sitting at your sofa, you can actually touch the vehicle, feel the vehicle, sit inside the vehicle, experience the vehicle, and even talk to the sales executive and sort out your queries. And this is, and I've shown you this two example. The left side is nothing, but it is a virtual showroom of Toyota in India itself. So this is the way the industry is moving. Where probably maybe another 5 to 10 years, you will start seeing all those showrooms converting into a smaller boutique showrooms, and you just go there and they will give you a VR kit, and then you will just wear it, and then you will have all your answers done in there. Just imagine the kind of cost saving it will have, and the productivity and the real use of the money can be there. This is something I think is already happening in India itself, especially in Delhi, where you know that mobility as a service, where you have one pass for each and everything. So all the transport and transport related services are interconnected. And I think, especially with the people who have traveled to the Europe, they know that, and with one ticket, they can roam around in the city and use multiple modes of the transport. And mobility as a service is, emerging as another area uh, where the growth is happening. And in many parts of the India also is using this, where you will have a single comprehensive on-demand mobility services, and that will, that's a single application or a single payment channel, and then you can access all the facets of the transportations, especially the personal transportations. And I don't have to tell you that, and this is brings so much of new business models, new way to organize and operate the various transport options, uh, advantages for the transport operators in terms of the improved user experiences. A lot of informations are getting generated, and a lot of earlier the opportunities which was not unmet are getting served now with the help of the mobility as a service. So this was some of the topics which I wanted to cover from an automobile perspective, but I thought that let me cover the manufacturing aspect also. And there is a philosophy called digital twin. And this time I seriously asked this question: if anybody can give me any example of the digital twin. Anybody? Okay. Sorry. No participation. I'll wait for the Q&A towards the end. But I think the biggest example of the digital twin is nothing but your Google Maps, which you use every day. Isn't it? So this is a digital twin. You know that this is a physical space and this is a digital space, and everything which is there in the physical space has been converted into a digital. So this is the biggest example of the digital twin, where the cyber physical systems, what I was talking about in the beginning. And just imagine that, if the Google Map starts, while it gives, but it starts overlaying the weather itself. It will start showing you the emergency vehicle itself. And, if there is some accidents, declare accident. So this digital twin is also emerging as another area in this era of the industry 4.0, which is solving multiple problems. And I'll just show you that how it is doing it and how it is being utilized in the manufacturing and the industry. So this is a typical oil refinery, and we all know that how the oil refinery functions. You have, the crude which is coming, and you from one side you are, feeding the crude, and the other side you are getting multiple products by treating in multiple ways. So you're getting LPG, gasoline, you're getting kerosene, you're getting, sulfur, what there is of course by asphalt, everything are the gases and what all you can produce with the help of the crude oil. And I don't have to tell you who is aware of that. So you have gases, you have light oil, you have heavy oils, you have solids, and you're getting aromatics also. So this is about a pilot project which was done by a large Indian IT company with the service provider, which is a French oil company. And I think you can guess the name of the company. It is India's largest IT company and French oil company. I think everybody knows its total. So the problem was given to them is that, they were unable to do the mass balancing that from one side, the crudes, just imagine that 200,000 barrels of the crude is getting as an input, and then you are getting so many products out of it. And they were just not able to get this data. And only the next day, this data was available that how much we have produced with the so much of input. And that was a core problem statement, which was given to the TCS, the IT company, and they have been asked to work on it. What they did? They created a digital twin. So a digital twin is a virtual representation of a physical assets. And in this case, I have taken this as a refinery, a pipeline, or entire oil field. And it is a constantly evolving data-driven model that mirrors its real-world counterparts. Sensors embedded in physical equipment feed data into the digital twin, enabling continuous monitoring of performance, health, and environmental impact. So what they did is that they created a digital twin. And you know that all the sensors which is there in the refinery were connected with this digital twin. And they were getting they have converted the entire refinery into a digital refinery in which you can see physically which pipeline going where and all that, and which sensor is there. And they have started getting a real-time monitoring and data. How it helped? They started getting the accurate mass balance. Second thing is, with the digital twin, you can actually see that what is going wrong and where it is going to go wrong. Because if the balance is changing or somewhere it's heating up, somewhere there is the stress is coming, so you know that what is to be done, and you can do the preventive maintenance. And with these two things, I think the resource optimization is something which is easily achievable. So this Industry 4.0 has also given us the solutions which were earlier not available. And with the integration of the technology with the physical space has solved multiple problems which were existing earlier. The result of this whole pilot project was the mass balance which they used to get next day, they started getting hourly. The manual corrections which they used to do, they were doing 400 corrections every day, it reduced to 10. All the calculations which they used to do, which used to take them 6 hours, with the help of the digital twin and the algorithm, they were able to do that in 10 minutes. And the best thing is that with the algorithm along with the digital twin, getting the data from the physical infrastructure, there was zero error in the mass balance. So efficiency, productivity, quality, resource optimizations, just think at what level it would have gone. So this is what the Industry 4.0 is bringing and creating the opportunities to solve multiple problems or the issues which were kind of unsolvable at some point of time. Some of my advice and my suggestions is especially to the academia and even for the students' perspective is that the labor market related to the industry is progressively demanding profiles of engineers who know and handle Industry 4.2 associated technologies. Different and diverse job profiles are now required. People are looking for, specialists in informatics, robot programming. Of course, software engineering, data analytics will be there, but then the cybersecurity and the physical PLC programmers also. In a similar sense, at education levels, I'm sure that the academia also need to cover the challenges and the opportunity which the Industry 4.0 is possessing. And for the next generation of the industrial engineers, the training is going to be the key. And that is why it's very important that the academia, especially dealing with they should expose the engineers with what is happening in this era of Industry 4.0, so that they can prepare themselves. The training can happen, and once they get into the other side, which is basically into the when they join any organizations as a maintenance engineer, as a production engineer, as a design engineer, as a research and development engineer, they should know that what is happening on that side, and they should not, not napping. And they must be very, it's important that, they should be trained on these crucial technologies, and at least they should be aware of that. They should have the exposure of the same, so that they will be able to deliver better. Two lines, and I'm going to close my session. If you remember that there was an era when we used to call oil is new dollar. That was the 20th century era. I think this is the era where data is new dollar, because the data is solving the problems. At the same time, data is bringing multiple opportunities, not just for the conventional players, but also for the new entrepreneurs. So that's all, from my side. Thank you so much. Over to you.
Thank you, sir. So this is question and answer time. Anybody, if you want to ask question, please ask.
Mr. Navneet,
Sir,
I have one question.
please.
What are the key challenges to implementation of Industry 4.0?
See, I think in one of the slide I covered that also. The problem is that the change management. I think the biggest challenge which we face is the change management, because we are used to of one way of functioning, and over a period of long time, and whenever a new innovations or the new technology comes, there's a lot of resistance which we face in the industry for the implementation of the same. So change management is the important aspect. And of course, the other aspect, which is more not technical, but more commercial, is the CapEx. Because you need to do this exercise of that when you bring the technology, then what is going to be your benefit out of it also. So I think these are the two questions which we need to answer before we get into this.
Thank you, sir.
Please, sir. I also want to know your view about the AI impact on this Industry 4.0.
Going to be huge.
It means what's the
But
impact of artificial intelligence?
No, of course. So see, with the artificial, big data and artificial intelligence, if you just marry both, with the large language model, that. And this is so that it's very simple if I answer you that. What is AI? The difference between Google search and the AI is that the Google search is something which is learning. The AI is something which is learning every minute, every second. The more the data you feed, the more it is learning. That's the difference, largely in a layman language, if I say
Definitely.
that. So just imagine a situation in an industry or in a manufacturing setup where you have, AI-driven process and you are getting a real-time data. Because in a normal setup, you get data, then you go back to your IT integration team, you feed the data, you give them the input, they work on the algo, then they come back with the solution, you test it, you have some questions, you go back, they correct it, they come back. But just think with the AI ML, when they have a real-time data available, how shortened this process would be. So
Yeah.
AI is, of course, AI is going to change. There is, of course, there is a lot of buzz about jobs and this and that, but I sincerely doubt that it's not going to happen. Of course, some set of work might move because of the AI integration, especially in the manufacturing and the industries. But at the end of the day, we are human. Emotional quotient and emotional intelligence has no option. But to answer your question, it's going to have a big impact and very positive impact, because then your efficient, just imagine the kind of efficiency you will get with the real-time corrections.
Right.
So your productivity will improve, your efficiency will improve, your targets will be met. So that is going to be the role of the AI in the industry.
Okay, thank you, sir.
Sir, good evening, sir. Hello.
Yeah, Rajesh, please.
Hello, good evening. Sir, actually, I have worked in industry like Gajra Gear and Mozarware Private Limited, and there was a lot of automation in Mozarware. So what I found, due to automation or Industry 4.0, can you elaborate a little bit how the sustainable development can happen with the help of 4.0? Because certainly the productivity enhance everything, even the worker will become more smart. How it will impact the sustainability factor and also the employability factor? Because there is some sort of skeptical in workers' mind. It may take their job. So how these problems can be tackled in industry perspective?
So two answers. And one, let's deal one by one. I will cover your second question first, and then I will answer your first question. It's basically about the employability. Rajesh, when we started, bringing the robotics in the line, the same question was there. No, today your car is manufactured by the robots. No, it is not manufactured by the humans. You know that your entire welding line is run by the robots. Only the TCF line is basically where you're putting the dashboards and you're fitting the other things. But your structure panel is made only by the robots. So this question has come. It will repeatedly keep on coming to us that the jobs, of course, then you will have other avenues, because it's like, if I give you a very answer is like, you have worked in the Gajra gear, so I think you will connect. So you have a bottleneck. What we do in the manufacturing or in industry is that you have a R&D operations. You know that where your bottleneck is, right? And you start working for that bottleneck. You isn't it? What we do in the factory, there is a bottleneck. As a team, we work on this bottleneck. We correct this bottleneck.
Yes.
But this correction will make bottleneck somewhere else.
Yeah. Yeah.
And you see, bottleneck is like energy. Bottleneck is like energy, never be created nor destroyed. Once you improve this, so you have you have a flow. There is a bottleneck. You correct it here, but that correction will take the bottleneck to somewhere else. And that is why all of us has job also. Let's put it in this very honestly. So especially like when the robotics has come in automobile industry, the same question was asked. Today, the industry 4.0, the same question is asked. My answer to this is that probably some of the profiles will get obsolete. No doubt about it. Because let's say that a software engineer. I'm giving you one different example, not just industry. I'm just connected also.
Right.
The codes would be written by the AI now. It is already writing, isn't it? It's already doing it. You see this every day. But it doesn't mean that the software engineers are not working on it. But now they have started using the AI and started creating the new answers. So, their role got changed. Maybe from algo to how to use the AI, especially with this recent Chinese thing happening, which is also open source and cheap. Right? So they can, they can find better solutions for some other problems. So I think that even in the industry, the roles will change. Whatever impact happened because of the robotics or the automation introduction in the industry, probably the same kind of impact you will face. There might be some jobs which will become irrelevant because the more automation you will bring, the less human interface will be there. But at the same time, I believe is that the new source or new business. That's why, that's why if you see my presentations, I did not speak about much about manufacturing, but about the opportunities.
Yeah.
So you probably the jobs will go down in one area, but it will go up in another areas, and hence the balance will get established. This is how I feel, Rajesh. So,
Sir, actually, okay, sir. What I found as a industry 4.0, being a mechanical faculty, what we found the job aspect are more and more increasing at the side of IT or IT enabled services, which would be useful in manufacturing industry. But being a mechanical engineer, what the people are seeing, now the scope of mechanical is not that much, and that part would be taken by the IT guys. So this is I think, wrong perception, because at the end of the day, mechanical engineer would have to train themselves to these technology and to adapt the new changes. Am I right, sir?
Rajesh, can I assume that all of us we are here are largely the mechanical, electrical field, or there are people from the other streams also? Manoj,
Core
Dr.
branches,
Manoj?
yeah.
All branches. Okay. So
Core.
because no, okay. So I wanted to answer, but I don't want to offend anybody. That is why I asked you this question. So, Manoj is aware that, a few months back, I was in MITS also giving one lecture. And the same question asked. So that is why I just thought that I'll cover this here. I'll be very honest with you. I'm also a mechanical engineer. Okay. I'll be very honest. I mean, I don't think that the job for the mechanical, electrical, electronics engineer or civil engineer is going to go away. No. No. See, let's put it in this way. I just take it from my own, presentation. I spoke about autonomous car. Correct? I talk about the software-defined vehicle. I talk about the VR, AR. Okay. Now you tell me, autonomous vehicle has got tires, na? Who make these tires?
Okay.
Automobile vehicle is made of iron. Who make iron? Steel.
Mechanical.
Aluminum. Multiple alloys. Who make these alloys? So software could be anything. Without hardware, software cannot work. It is of no use. See, AI will come from where the data will come. Data will come from the sensors. Sensors will be fitted somewhere, but that somewhere would be made by the mechanical engineer. So I know that this is because in my circle also a lot of people ask these questions. But it's about the glamour and the charm. That's why I'm asking that people should not feel offended. But my point is that all the branches has their role to play. See, IT and software.
Merging.
It's a only thing which I was trying to cover here, Rajeshji, is just to our mechanical, electrical, civil, electronics engineers should also get exposure. They should also be with this. Just imagine if they know this and they will know this also, then what will be their value proposition in the market once they go in this job market?
Right.
So that is why I said, and that is why those 4 lines I mentioned, is that if you start giving exposure to our students, these are the changes, rapid changes happening in the industry, and they are well versed with these changes. When tomorrow they sit in any interview and they will cover this aspect, I think they will crack it. Yeah,
Right.
I also go and I also take a lot of interviews now. Just imagine an engineer sitting in front of me from a college and giving me answers on the, from not just the, I'm not talking about the thermal, all those, the typical mechanical branch, things. And you start covering the other aspects also. I'll be impressed. So that is why I was just trying to say is that one is that with the AI/ML, my only point is that job profiles will change. Some people will lose here, some people will gain here. So the equilibrium and the balance will come into the picture. The second thing, the core branches I personally feel that we should give confidence to our students. It's not good. Without hardware, no software. What is the use of software without hardware?
Right. Software will run on hardware.
No hardware, and hardware will be made by the engineers.
Right, sir.
So it's
Okay,
not
sir.
going
Thank
anywhere. And second, आपका जो sustainability का point था. So on your
Yeah,
sustainability
sir.
point, I think, see, that was more from the. That's why I use the two lines. Is the data is new dollar. See, sustainability, you can only work on sustainability when you have the data. Industry 4.0 is helping you to get the data. See, what is my consumption, real-time consumption. So imagine my real-time consumption is this much, and my real-time electric usage is renewable. So I am meeting my sustainable goal. Na? So today, what is happening? You know that what industries are doing right now? There is in the grid, there is a bidding. You do bidding for the electricity. I hope you are aware of that. The bidding happens. So you have your line, you have your DG sets for the breakdowns. You also bid for the electricity consumption. And then you can always see that, am I getting my electricity from the solar sources or the renewable sources or the coal? And if you are, like, for example, you're using a X unit of your electricity in a month, and you know that 50% of that is coming from renewable. How will you know about it?
Renewable solar.
You need the real-time data analysis, and that's what the 4.0 is making you, possible for you, where your consumption, the users, the buying, and then you can have your sustainable goals in front of you. So that is it's largely basically the data or the information which is flowing because of the 4.0 will help you to work towards your sustainable goals.
Right. Thank you, sir. Thank you very much, sir.
Thank you, Rajesh.
Nice information.
Thank you so much.
I have a question.
Yes, Adeshi.
After Industry 4.0, Industry 5.0 is upcoming, right? So if we embed the AI and ML inside the machines, so the whole generation will go jobless, or there will be jobs remaining for the generation?
I just answered that. Please understand, my personal thought is that nobody can replace this. So we are all made by the God. And that is why you won't believe that I am also reading now the emotional intelligence, emotional books on the emotional intelligence, emotional questions to be relevant in the industry. Because yes, the AI will do what AI has to do, but AI cannot replace the decision making, the emotional decision making, the emotional question aspect that human will do. So I sincerely doubt is that while the AI is a self-learning, it's keep learning, tomorrow it will become like human, all that things are there, but I doubt it. I think at the end of the day, we are human and we know what we are doing. Comes to the job, I think I just answered to the Rajesh, is that yes, in some areas, the jobs will go, but in many areas, because it is also throwing a lot of opportunities for the new businesses, new entrepreneurship, new profiles. The jobs will start creating there, the balance will come into the picture.
Thank you, sir. Thank you.
सर मेरा एक क्वेश्चन था सर.
बोलिए दिनेश.
सर एक्चुअली अभी देखा जाए तो इंडस्ट्री 3.0 के इंडस्ट्रीज में जो है ना पुराने जो प्रोसेस चला रहे हैं केमिकल इंडस्ट्रीज और जो मास प्रोडक्शन में काम करते हैं मैन्युफैक्चरिंग, जैसे मैं ऑपरेशन एंड मेंटेनेंस में 10 साल रहा हूँ और अब एकेडमिक में आ गया हूँ, तो मैं देख रहा हूँ कि जो 3.0 से 4.0 की तरफ भी वो जाना उनको मुश्किल है और 5.0 के लिए तो टफ है ही है. तो क्या जैसे मैं जिस टाइम पास आउट हुआ था 2008 में, तो उस टाइम ये इंडस्ट्री 2.0 से 3.0 पे भी जाना, ऑटोमेशन और इलेक्ट्रॉनिक्स इक्विपमेंट्स का यूज कर पाना भी टफ हुआ था. बट आज इंडस्ट्री इतना ग्रो कर गई है 4.0 के साथ, तो 5.0 के लिए हम स्टूडेंट्स को हम फ्यूचरिस्टिक, जैसे हम कोई पंप में प्रॉब्लम आने वाला है और उसको प्रिवेंटिव हमको अलार्म जनरेट हो जाए और वो इतना इंटेलिजेंट सिस्टम हम जनरेट कर दें, वो हम कैसे कर पाएंगे? थोड़ा सा सर मैं जानना चाहूँगा प्लीज सर.
मैं एक्चुअली यादव जी क्वेश्चन नहीं समझ पाया. आपका पॉइंट ये था कि एक तो इंडस्ट्रीज के अंदर जो चेंज होता है 2.0 से 3.0 वो थोड़ा सा डिफिकल्ट होता है, आप ये कहना चाह रहे हैं, लोग उतनी जल्दी मूव नहीं करते हैं, करेक्ट?
यस.
तो वो मैं, अगर आपको याद होगा तो मैंने वो स्लाइड बनाई थी चेंज मैनेजमेंट की, वो एक्चुअली वही प्रॉब्लम है. दैट इज द प्रॉब्लम. मैंने वो
Yes, sir.
आप सोच रहे होंगे ये इररिलेवेंट स्लाइड है, बट वो मैंने रिलेवेंस पॉइंट, क्योंकि दिस इज व्हाट वी फेस, यानी द मोमेंट यू ब्रिंग समथिंग न्यू, सी in the life, change is the only constant, but
Yeah.
human always resists change. So
Yes.
what we, so that is the case with the industries also, because industry is run by the people, and people are
Yes, sir.
nothing but human. So the human resist change, so they resist change at home also, they resist change at job also. So जो
Yes, sir.
चला रहा है वो चलने दीजिए। तो चेंज मैनेजमेंट हमारे लिए एक बहुत बड़ा चैलेंज होता है, और वो एक्चुअली आप देखेंगे तो जो 4.0 भी वो थोड़ी मेच्योर थोड़ी हुआ है अभी। आई मीन इट्स जस्ट यू नो इट्स इवॉल्विंग, मे बी द वेस्टर्न वर्ल्ड हैज टेकन अ लीड, but even now we are also catching up, multiple things are happening, but the half of the globe is still not there. But
Yes, sir.
you know how many countries in the world are the industrial countries? So we know that there is only limited set of the countries who are, they are in the industrial and the manufacturing sector. Africa, of course, you can exclude, barring the, let's say, there was some. So I mean, I'll not get there. तो वो एक चैलेंज है दिनेश, जहां पर
Yes, sir.
that's why the training is very important, and the larger picture need to be shown to the employees, is that this change is going to bring the fruits later. एंड मैंने जो प्रेजेंटेशन कवर किया था, मैं इसीलिए मैंने बोला कि देखिए, एक तो ये है कि ये 4.0 हो रहा है, लेकिन 4.0 होने की वजह से मार्केट में क्या हो रहा है। तो मैंने आपको शायद वो पिक्चर दिखाने की कोशिश करी कि धंधे में क्या हो रहा है। आई मीन, अगर मैं देसी भाषा में बोलूं,
Yes,
धंधे में
sir.
क्या हो रहा है, आई मीन हाउ इट इज चेंजिंग द बिजनेस। तो आई टुक यू आउट फ्रॉम मैन्युफैक्चरिंग। मुझे पता है कि आप लोग सब एकेडेमिया से है, आपको पता है कि मैन्युफैक्चरिंग में, प्रोडक्शन में, आई हैव आल्सो डन, आई वाज पार्ट ऑफ द प्रोडक्ट मैनेजमेंट, आई हैव आल्सो डन दैट बिट, आई हैव सीन ऑल माय टाटा मोटर्स प्लांट्स एंड मेनी अदर प्लांट्स वर्ल्ड वाइड आल्सो। मैंने वो कोशिश किया कि मैं थोड़ा एक डिफरेंट एस्पेक्ट लिया कि हाउ इट इज चेंजिंग द बिजनेस आल्सो, जस्ट नॉट दी। सी मैन्युफैक्चरिंग में क्या है, आपने 4.0 किया, आपका प्रोडक्टिविटी बढ़ गया, आपका एफिशिएंसी बढ़ गया, आपका क्वालिटी कंट्रोल हो गया, आपका प्रिवेंटिव मेंटेनेंस हो गया। सो बेसिकली बहुत सारे इसका फायदा आपको ये हुआ कि देन जो चीजें आप अब सोचिए कि आपको पता है कि ब्रेकडाउन, आप महीने साल में एक बार ब्रेकडाउन यहाँ होगा, या जो भी आप प्रिवेंटिव मेंटेनेंस करते थे, अब वो प्रिवेंटिव मेंटेनेंस की तारीख याद करने की जरूरत नहीं है, बिकॉज द डेटा इज टेलिंग यू कि बॉस आज करना है, isn't it?
Yes, sir.
रिमेंबर
Yes,
दैट,
yes,
आपको
yes.
आप लाइन पे काम किए हैं, तो अपनी तो डेट
Yeah.
फिक्स होती थी प्रिवेंटिव मेंटेनेंस की, अगर आपको याद होगा।
Right. बिल्कुल सर,
2 दिन
bearing
प्लांट
बंद।
बंद रहेगा, मेंटेनेंस चल रही है, ब्लॉक क्लोजर है, यही होता था। लेकिन
Yes, sir.
आज आपको पता है कि अरे बॉस, ये लाइन कल गड़बड़ा जाएगी, इसको आज रात को ठीक करना है। तो वो दिस इज व्हाट इज गिविंग यू, ठीक है ना,
Yes,
बिकॉज
sir.
द रियल टाइम डेटा इज हेल्पिंग यू टू टेक द राइट कॉल एट द राइट टाइम, सो दैट your line is not suffering, your production is not suffering, your production efficiency is not suffering, quality is not suffering, and all. So
Yes, sir.
वो हो रहा है। So that is happening, but उसके साथ साथ this is also changing the game in the business side also. So both sides it is changing, because it's throwing so much of opportunities. People are people are leveraging those up. That's why I written the line that it is becoming a backbone of multiple entrepreneurships,
Yes,
because
sir.
they are seeing कि अरे ये आने से ये कर सकते हैं, and these ideas becomes unicorn later on. आपको पता ही है, स्टार्टअप, यूनिकॉर्न, ये सब चीजें पहले कहाँ सुनते थे हम लोग चीजें,
Yes, sir.
because the data, that's what I said na, data is new dollar, and
Yeah.
4.0 is nothing but data, isn't it?
Yes, sir.
So
Yes, sir. Thank
सेंसर्स ये लगाए हुए, डेटा और डेटा बेस्ड डिसीजन मेकिंग। अगर मैं निचोड़ निकालूं तो इट इज अ डेटा बेस्ड डिसीजन मेकिंग। अब
Yes, sir.
डेटा बेस्ड डिसीजन मेकिंग करूं और डेटा बेस्ड बिजनेस मॉडल बनाऊं, अपॉर्चुनिटी तो दोनों ही है।
Yes, yes, yes.
तो वो है, तो एक चेंज मैनेजमेंट वाला जो आपका पॉइंट था वो मैंने कवर किया। दूसरा क्वेश्चन मैं शायद आपको भूल गया, एक और आपका पॉइंट क्या था कि स्टूडेंट्स को कैसे प्रिपेयर करें।
यस यस, वो एक्चुअली क्या है कि अभी ठीक है, हमारा चेंज ओवर हो रहा है, तो अभी हमें फ्यूचरिस्टिक ऐसे इंजीनियर तैयार करने होंगे जो मतलब जो इंडस्ट्री 5.0 की सोच रखें, बट कहीं ना कहीं ह्यूमन का जो इंटरफेरेंस रहेगा वो तो रहेगा, क्योंकि वो उसको आई थिंक हम इतने जल्दी रिप्लेस कर पाएंगे कि नहीं कर पाएंगे, वो एक सोचने वाला विषय है, बट हम कोशिश कर सकते हैं, तो हमें वैसा तैयार करना पड़ेगा स्टूडेंट को। राइट सर,
एग्री दिनेश, मैं इस पे बस एक चीज, मैंने वो क्यों डाला था 5.0, जानबूझ के डाला था, क्योंकि
यस
क्या है
सर।
कि मुझे पता है कि सेशन 4.0 का है, बट फिर भी मैंने डाला। मैं आपको बताऊँ ना क्यों, मैंने सोच क्यों थी, क्यों मैंने डाला। मैं डॉक्टर विनोद से भी बात किया था, तो इज दिस बिकॉज देखिए 4.0 अभी तक मेच्योर नहीं हुआ है। अगर आप देखेंगे वर्ल्ड वाइड सस्टेनेबिलिटी गोल्स लेना लोगों ने ऑलरेडी शुरू कर दिया। इंडिया ने बोला कि 2070 तक हम सस्टेनेबल नेशन बन जाएंगे। मैं आपको अपना ग्रुप को बताता हूँ, टाटा ग्रुप ने बोला कि हम 2047 तक ही सस्टेनेबल बन जाएंगे। तो हम ये कहना चाह रहे हैं कि हम जितना नेचर को एक्सप्लॉइट करेंगे उतना ही नेचर को वापस देंगे। दैट इज व्हाट सस्टेनेबिलिटी इज, करेक्ट, इन लेमन लैंग्वेज, ठीक है।
या
मैं जितना यूज करूंगा नेचर को करके अपने कंजम्पशन के लिए उससे उतना ही मैं नेचर को वापस कर दूंगा, एंड दैट इज व्हाट यू कॉल सर्कुलर इकोनॉमी. सो यहाँ से आया, मैंने यूज किया, वापस दिया, तो दैट इज व्हाट सर्कुलर इकोनॉमी. सो आई विल नॉट exploit the mother earth anymore. I will keep rotating the resources which is already available in the system. I will not go for the fresh resources. So so the industry 5.0 is going into that direction, but it is very early. That's why I written 2021, because किसी भी evaluation को mature होने में 10-15 साल तो लगते ही हैं. आप देखिए 4.0 started in 2011, not yet mature, but it has become a talk of the town. You are also having a session on the same. तो हमारी जो बच्चे हैं, हमारे जो स्टूडेंट्स हैं, see, बहुत एकेडमी है सारा, इसलिए मैं बोल रहा हूँ, क्योंकि क्या होता है कि हम जब इंटरव्यू लेते हैं ना, तो कई बार ब्लैंक हो जाते हैं बच्चे, क्योंकि थोड़ा सा बुकिश रहते हैं, थोड़ा थ्योरेटिकल रहते हैं, है ना, प्रैक्टिकल नहीं होते हैं, या थोड़ा जो वर्ल्ड वाइड जो चेंजेस आ रहे हैं, प्रॉब्ली दे आर सो एनग्रॉस्ड इन देयर स्टडीज एंड बुकिश, ऑल दोस थिंग. थोड़ा सा ये जो, दिस इज द 21st सेंचुरी, तो जो सामने बैठा होता है ना बंदा, ही इज सीइंग मच मोर देन दैट, बिकॉज क्या आधे घंटे में आप आदमी का टेम्परामेंट देखते हो, फिर आपको पता है कि मेरे कंपनी में क्या चल रहा है, विल इट फिट और नॉट. So
Right, sir.
that is why it's important कि हमारे बच्चे should be aware of all the changes which is happening. तो मेरे ख्याल से it's too early to comment कि AIML, sustainability, मेरे ख्याल से वो भविष्य बताएगा अपने को, बट हमारे बच्चों को ये एक्सपोजर होना चाहिए. इसीलिए मैंने वो लाइन लिखी कि आपको क्या है कि जहां पर ऑटोमेशंस हैं, जहां पर बिग डेटा का, जहां पर अपना ये 4.0 फैक्ट्रीज में यूज हुआ है, वहां पर ट्रिप्स हो, बच्चों के राउंड्स हो, जाके देखें वो ऑटोमेशंस, और जो साइबर और फिजिकल इंटीग्रेशन के साथ किस तरीके से इंडस्ट्रीज काम कर रही है, वो एक्सपोजर बहुत हेल्प करेगा. तो
बिल्कुल सर,
वो मेरे ख्याल से अगर आप देंगे ना, तो कि आप जो इंजीनियर, अभी हम लोग बोलते हैं ना यार एम्प्लॉयबल इंजीनियर्स, वो आप ज्यादा एम्प्लॉयबल इंजीनियर्स बनाएंगे.
यस, थैंक यू सर.
Is there anybody else? Any other participants who wants to ask questions? I think we should proceed for the conclusion. Thank you, sir, for your detailed information. Now I invite Organizing Secretary of this FDP, Mr. Vinitra Singh Kushwaha, to propose vote of thanks. So,
Good evening again, everyone. I am Vinitra Singh Kushwaha on behalf of the Organizing Committee of 1 Week Faculty Development Program on recent advances and applications of manufacturing in Industry 4.0. Extend my deepest thanks to the eminent keynote speaker, Mr. Navneet Singh Rajput, General Manager, Tata Motors, Ahmedabad, for sharing the topic of need of our opportunities in Industry 4.0 with us. It was such an enlightening and thought-provoking session. The insights you shared on opportunities in 4.0 has opened new avenues for us to explore and implement in our own academic journey likewise. The marketing tips you provided will undoubtedly guide us as we strive to enhance our teaching, research, and overall professional development. This is the last session, but the way participants are attending and listening enthusiastically, hence a big thank goes to the participant also for being passionate for this enriching session. Thank you all once again.
thank you, sir. And thank you,
Thank-
Navneet, sir, for giving
Thank
the
you so much for listening me. Thank you so much for your question answer. Thank you so much.
Thank you, Navneet.
Thank you, Dr. Manoj. Thank you, everybody.
Thank you, sir.
So, dear participant, please stay online. Our next and last session, the validatory of this 1 week faculty development program, will be started soon. The feedback of last session is very much important for attendance. Feedback link will be given in chat box at the end of the validatory session. This is very much important to submit. Please submit it within time. There is some important instructions for you. The quiz will be displayed on your login in ATAL portal at 8 p.m. to 9 p.m. It is requested to all, please solve and submit the quiz in the given time. The minimum qualifying score of this quiz is 70%. The feedback link is also provided on your login on ATAL portal. Please fill and submit it within given time. Both the link will be disabled after given time. So it is requested to all, please submit both the quiz and feedback within time. It is mandatory for all. The certificate of this faculty development program will be based on your attendance and score obtained in quiz on today. After submitting both, your certificate will be uploaded on your ATAL login. You can download from there. The instruction in the form of flowchart has also been given in WhatsApp group. So participants, today all of you will submit two feedback. One on link given in the chat box and the other one on your login on ATAL portal. Please keep it in mind. Thank you, and please stay online. We will start soon. Good evening, Dada.
Good evening.
Good evening, Dada.
Good evening. You are
Good evening, sir.
you are not allowing me to relax.
Good evening, sir.
And then I was not sure whether I will be able to connect myself or not.
Dada, tomorrow is Sunday.
Yeah, tomorrow is Sunday, but I have brought some work with me. I do not know whether I will be able to concentrate, but I want to relax. लगा दी
नहीं मिला
क्यों
धामी नहीं मिला अलकापुरी 50 जगह पूछ लिया मिला ही नहीं।
अलकापुरी में कैसे मिलेगा तुम इतना जगह गया
हेलो?
है 34
हाँ
से क्यों
सर,
नहीं
अभी आ सकते हैं।
वहाँ
Dada, good evening.
Good evening.
Good evening, Dada.
Very good evening to you all.
Our chief guest is joining soon. Please stay online.
Good evening, sir. Good evening, sir.
Evening.
Dear participant, please stay online. Our next session will be started soon.
Sushil sir, I think sir has joined. I centers iPhone. This name appear. Sushil sir, is make host.
Sushil sir.
Sir, which name sir has joined?
I centers iPhone. I think.
Yes. Now sir is co-host.
Good evening, sir.
Good evening, Manoj ji and good evening. Sharp. Is able to hear me?
Yeah, sometimes it is blared.
Good
Good
evening, sir.
evening, sir.
Good evening.
Nikaran, I think
So,
we should start.
yes, sir. Yes, we will start.
My voice is clear?
Yes, sir.
Sneha?
Yes, sir, it
Okay.
is clear.
Okay.
Good evening, all. So before proceeding for validity session, dear participant, there is some important instructions for you. The quiz will be displayed on your login on ATAL portal at 8 to 9 p.m. It is requested to all, please solve and submit the quiz in the given time. And the feedback link is also provided on your login on ATAL portal. Please fill and submit it within given time. So now we will proceed for valedictory session. Good evening all. Respected distinguished guests, Director Sir, Working President Sir, CAO Sir, Principal Sir, Dean Academic Ma'am, teachers, staff members and participants. It is my privilege to welcome you to the valedictory ceremony of 1B Faculty Development Program on recent advances and applications of manufacturing in Industries 4.0, organized by IPS College of Technology and Management Gwalior, supported by AICTE Training and Learning ATAL Academy Scheme. Today, we gather here to celebrate the successful completion of this program and to recognize the dedication and commitment of our faculty members. So on this occasion, I invite Mr. Raju Sharma, Head Department of Computer Science, IPS College of Technology and Management, for the welcome speech. Raju sir, it's over to you. Raju sir. There may be some technical glitch. Raju sir, are you here?
Hello.
Yes, sir.
Am I audible, ma'am?
Yes, sir, clear.
Okay. Thank you, ma'am. Respected dignitaries, dear colleagues and participants, good evening to everyone present over here. It's really my honor and privilege to extend a warm welcome to all of you on this occasion of the valedictory function of 6 days faculty development program on recent advances and applications of manufacturing in Industry 4.0, sponsored by ATAL Academy. I, Raju Sharma, Head of Computer Science and Engineering Department, IPS College of Technology and Management, on the behalf of our organizing committee, hearty welcome our guest of honor, Mr. Avinash Misra, President of Quality Circle Forum of India, and former Vice President, Godrej Consumer Product Limited, for sparing his precious time to grace this event. I extend my warm-hearted welcome to Dr. Arun Kumar Tyagi, Director, IPS Group of Colleges, Mr. Ashwini Misra, Working President, IPS Group of Colleges, and Mr. P.K. Ghosh, Chief Administrative Officer, IPS Group of Colleges. I also welcome Dr. Anurag Garg, Principal, IPS College of Technology and Management, Dr. Jyoti Misra, Dean Academics, all heads of various departments, faculty members, and participants from different part of country. With this, I once again welcome you all. Thank you all. Thank you, ma'am.
Thank you, sir. Now I invite Mr. Vineet Raj Singh Kushwaha, Associate Professor, Department of Computer Science Engineering and Organizing Secretary of this one-week faculty development program to brief about our faculty development program. Sir, it's over to you.
Good evening, everyone. The ATAL online one-week faculty development program on recent advances and applications of manufacturing and Industry 4.0 successfully provided a platform for faculty members, researchers, and industry professionals. The FDP featured expert lectures, case studies, and interactive discussions on cutting-edge advancements for Industry 4.0, smart manufacturing, and digital transformation. The event had renowned experts from IIT, leading industries, and global institutions who shared insights into various aspects of advanced manufacturing. Here, I am glad to inform you that more than 200 participants enrolled for this FDP, and 160 plus participants attended the whole program enthusiastically and actively. The FDP was inaugurated by the Professor B.K. Jain, former Professor IIT Kanpur, who highlighted the importance of Industry 4.0 in shaping the future of manufacturing. The FDP was divided into 13 sessions covering all the sophisticated and advanced manufacturing technologies and methods. The first session was headed by Professor B.K. Jain, former Professor IIT Kanpur, who highlighted the electrochemical machining techniques, tool design, and optimization for precise manufacturing. In the second session, Dr. Varun Sharma, Associate Professor from IIT Roorkee, focused on the advancements in micro-machining, nano-finishing techniques, and their application in high-precision manufacturing. The third session was on micro-characterization of material upon machine, and session was delivered by Dr. Meghanshu Vasist, Professor IIT BHU. He concentrated on the understanding material behavior during machining, advanced microstructural analysis techniques. The next session delivered by Dr. Ankur Jain, Associate Professor, Hiroshima University, Japan, spotlighted the role of nanotechnology in enhancing material properties and manufacturing efficiency. What a session it was. Similarly, day 3 and 4 covered the topics Modern Material for Industry 4.0 by Dr. Vijay Verma, Associate Professor by BIT Jhansi, use of condition monitoring techniques and online vibration monitoring for optimum maintenance by Mr. Amit Mehta, Vice President, Wonder Cement Limited, Udaipur, government initiatives for MSME startups entrepreneurship for Industry 4.0 by Mr. Gopal Kumar Sinha, Director in charge MSME, Sri Vijayapura. Additive technology, 3D printing and power manufacturing by Mr. O.P. Dwivedi, Works Manager, Ordnance Factory, Jabalpur. Mr. Rajesh Gupta, Assistant Works Manager, Ordnance Factory, Jabalpur, delivered session 9 on the topic Digital Twins, Technology in Micro-Machining for Real-Time Process Simulation and Optimization. Sustainability and Green Manufacturing in Industry 4.0 was the topic of session 10, where Professor J. Ramkumar, Professor IIT Kanpur, underlined the eco-friendly manufacturing practices, waste reduction, and energy-efficient production system. On the day 6, session 11 was delivered by Dr. Elamaran Jayamani, Soin University of Technology in Malaysia, on the topic Composites for Dielectric Applications in the Past, Present, and Future. The session 12, graced by Dr. Ravi Shankar, Professor IIT Tirupati. Dr. Ravi emphasized on smart abrasive flow finishing system to finish complex additive manufactured features. Opportunities in the Industry 4.0 era was the theme of session 13, which was delivered by Mr. Navneet Singh Rajput, General Manager, Tata Motors, Ahmedabad. I want to extend my heartfelt thanks to our eminent speakers who are experts in their respective fields for sharing their expertise and experiences with us. I encourage each of you to take the lessons learned here. Once again, thank you all for your active participation. Thank you.
Thank you, sir, for your brief description. Now I invite CAO IPS Group of Colleges, Mr. P.K. Ghosh, to address the audience. It's over to you, sir, Dada.
Okay, thank you, Dr. Snehika. Good evening to everybody. Special good evening to um, our honorable guest on this occasion, Mr. Avinash Mishraji. And of course, other dignitaries, organizing committee members, and the participants from far and near. I was just thinking that, appearing suddenly and creating havoc throughout the world, COVID, before leaving, left behind a blessings in disguise for us, and that is virtual mode learning. We are able to connect the experts located in various places throughout the world, and the learners can learn at their comfort zone and at suitable available time. This is definitely a blessing. And at the outset, I would like to express our sincere thanks to AICTE and ATAL Academy for granting this program to our institute. Our institute has been able to contact the resource persons, the experts, the teaching fraternity, students, and of course, enthusiasts who could share their views, upgrade their knowledge, and develop expertise in the field as described by Dr. Bineet in different aspects of the subject. The success of this program will definitely depend upon the extent of the satisfaction driven by the participants, which perhaps we'll be coming to know a little later through their feedback. But this institute has been able to facilitate the process of sharing information, gaining knowledge by the participants, and derive benefit from the subject that they are working on. Of course, it has been a very good experience for this institute, the organizing committee members, and members of our faculty to share the knowledge, get the clarification on their different issues. And I'm sure that those who are engaged in teaching and research will definitely help them from this program. With these few words, I'm sure that the participants also have enjoyed this learning process, and we definitely would be planning to organize such kind of program in future with sponsorship from AICTE. With these few words, thank you all, and it is over to Dr. Snehika.
Thank you so much, sir, for your kind words. Your words always fill us with enthusiasm. Thank you so much. Now I invite all the participants to give your feedback. I request to all, please give us online feedback of this 1 week faculty development program. You can talk few lines about this 1 week faculty development program, how you experience and how you got benefited by this FDP. So please unmute and turn your camera on and say a few words about this faculty development program. Dear participants, it's over to you.
Manoj sir, good evening.
Good evening, sir.
Sir, good evening.
Good evening, Snehika madam.
Good evening, sir.
Anurag sir, good evening.
Good evening, sir. Good evening.
I would like to share my good evening. I would like to share my feedback on this FDP. I just wanted to take a moment to thank the coordinator of the FDP and my senior Dr. Manoj Narwaria sir, co-coordinator Dr. Snehika Srivastava madam, Principal Dr. Anurag Garg sir, Mr. Ghosh sir, and the entire organizing team for putting together such an amazing FDP. The insights shared by all the experts were invaluable. All the sessions were incredibly informative, and I gained a lot about the latest trend in Industry 4.0. The entire program was well organized, and I truly appreciated the opportunity to participate. Thanks again to everyone involved for this great learning experience. It was truly valuable. Thank you. Thank you very much.
Thank you, sir.
Thank you.
The next participant, please share something about this faculty development program.
Hello, good evening, ma'am.
Good evening, sir.
This is Navdeep Prabhakar from Kapurthala. Your program is very possible, very comfortable, very nice. All the host very experienced. All the sessions are very comfortable, very educated. I appreciate this program. Thank you.
Thank you, sir. The next participant, please speak something about.
Good evening, madam.
Good evening, sir.
Madam, I have seen all the sessions, and I found really very informative. And you have managed this session, these sessions very beautifully. Thank you very much, ma'am. Thank you,
sir.
each and every member who has spoken to here. Thank you, madam.
Thank you, sir.
Okay.
Anybody next?
Good evening, ma'am.
Good evening, sir.
Dr. Chetan Sharma. The beauty of this program is the blending of experts from industry and academia. All the sessions were very well planned and conducted. The resource persons were expert in their field and have very vast experience. So we learned a lot from this FDP, and I congratulate all of you, the coordinator, co-coordinator, and the persons who are behind the screen, who do a lot of work in making such programs successful. Once again, thanking you all.
Thank you so much, sir. The next.
मैम आपको और सारी जो ऑर्गेनाइजिंग कमेटी है उसको बहुत शुभकामनाएं और साथ में जो आपने कॉम्बिनेशन इंडस्ट्रीज और एकेडमिया का बना है और जैसा कि मैं खुद को महसूस कर पा रहा हूँ कि मैं भी इंडस्ट्री और एकेडमिया से हूँ दोनों का कॉम्बिनेशन तो काफी मतलब मेरे लिए एक बहुत ही जबरदस्त लर्निंग का एक वो रहा और मैं कोशिश ये करूंगा कि फ्यूचरिस्टिक जो डेवलपमेंट फ्यूचरिस्टिक जो रिसर्च एंड डेवलपमेंट और इंजीनियर्स जो बनाना है वो मेरी कोशिश रहेगी आपके इस प्रोग्राम से मैं बहुत अच्छा कर पाऊँ आपकी फिर से पुनः एक बार सभी टीम को और अभी सभी मेंबर्स को और होस्ट को बहुत बहुत धन्यवाद थैंक यू सो मच
Thank you, sir. And we hope we all will stay connected for next program, which will be organized by our team, our institution.
Hello. Hello.
Yes. Hello. Yes, sir.
Madam, good evening. This is Dr. Divakar from Karnataka, UT College, VTU
Good
Constant
evening,
College.
sir. Yes.
Thank you so much, Madam, for organizing such a wonderful workshop, FDP program. I had a very great experience with all presentations of the experts. The sessions were too good. we could learn a lot of things from this, especially what is required for the present scenario, Industry 4.0. So yesterday also I could listen to expert IIT Kharagpur professor. It was too good, and then, all your presentations, the video audio quality, everything was super, madam. The schedule maintained was very good. So totally overall, the FDP was too good, madam. I congratulate all the organizing committee and the college authorities for having organized such a wonderful FDP, madam. Thank you once again, madam. Thank you. Bye bye, madam.
Thank you so much, sir.
Good evening, ma'am.
Good evening, sir.
This is Dr. Gaurav Saxena from Rustomjee Institute of Technology, BSF Teganpur. Manoj sir is known to me, the Anurag Garg sir.
I also know
Good
you,
sir.
sir.
Oh, yes, ma'am. And the several faculties all are known to me. The
Yes, sir.
best thing was the teamwork, because the coordination was very good among the organizers. So it does well. And the content was also good, because the lecture on sustainability, which was delivered yesterday, was today's demand, because with the higher productions, it is required that there should be sustainability. And the timing of the FDP is also good, because throughout the day we are engaged in our college work as well as the exam duties. So timing is also good. So once again, thanks to all, and congratulations to all for organizing such as FDP.
Thank you, sir. Thank you so much. Anybody else?
Hello.
Yes, sir. Good evening, sir.
Good evening, madam. Dr. Pradeep Patil from SVC Indore.
Yes.
Thank you very much for such wonderful sessions which we have conducted for us. Definitely, the things which we have learned from here, we can definitely pass on these to our students for their benefit and for their technical growth. So thank you very much once again from our side to the organizing committee and the Institute IPS. Thank you very much.
Thank you, sir. Is there anybody else who want to share something about our faculty development program?
Good evening,
Yes, sir.
madam.
Good evening, sir.
I am Dr. Abhishek Jain, Principal, Ladina Institute of Science and
I think there is some technical issue.
Manoj Narvadia sir. He is my one of best friend. And Narvadia sir, congratulations a lot for completion of this fantastic FDP program. And I hope we will, I and my team members will join again in the next program organized by the IPS College. Thank you very much, madam.
So the
Thank you
event
so
shows
much.
the popularity of Narvadia sir also. I think the next
Yeah.
event will be more popular.
Yeah, Narvadia sir,
Yes,
Narvadia.
sir.
Thank you, sir.
The next, anybody else? If there is no one else who want to share, then we will proceed further. Okay. Thank you, all participants. We are fortunate to have our guest of honor, Mr. Avinash Mishra, President of Quality Circle Forum of India and ex-Vice President, Godrej Consumer Product Limited, who has graciously accepted our invitation to address us today. I would like to invite today's guest of honor, Mr. Avinash Mishra, to address the audience. But before this, I would like to take the privilege to introduce today's guest, Mr. Avinash Mishra. Mr. Avinash Mishra is General Manager in Godrej Consumer Product Limited, has overall 29 years of experience in different industries and 20 years within the FMCG industry itself. He is professionally qualified and possesses master's degree in economics and human resource management and industrial relations apart from LLB. He designed and rolled out various innovative HR practices which have helped Godrej to bag many awards, mainly Best Managed Workforce Award by Hewitt, Quinpro Awards, TPM Awards by JIPM Japan, Great Place to Work Award, CII EXIM, Bank Business Excellence Award, Indian Manufacturing Excellence Award. He has been awarded by the chairman of Godrej Group, Mr. R.E. Godrej, on commendation for affirmative action to fulfill company social responsibility. There are much more to say about sir, but due to lack of time, I made it in a short only. Thank you so much, sir. And now I invite Mr. Avinash Mishra to address the audience. It's over to you, sir.
Thank you very much, Snigdha. Hope I am audible.
Yes, sir, clearly audible.
Because I'm very sorry because I'm traveling and I had to stop my vehicle and I'm standing at petrol pump. Okay, because that was my commitment given to Mr. Manoj, R.P. Singh and Mr. Ghosh. So kindly bear me if connectivity is an issue. So
fine.
Honorable Mr. Tyagi, Mr. Ghosh, Mr. Manoj, Mr. R.P. Singh, and all the honorable and participants. It's my pleasure and honor to be a part of your 6 days faculty development program because I've been working more than 39 years with corporate, mainly in Godrej consumer product. And last year I retired as a vice president, and currently I am holding a position of president, Quality Circle Forum of India. It's a non-political and non-profit organization. So we have 35 chapters across India. So let me share my thought because I have heard very nice feedback from the participants, and I have also heard what has happened in last 6 days because this is a program for the faculties, practitioners, and many more participants. So it's a need of the hours to adapt the new advancement technology, which is not only in India, across globe. This change is happening very fast. So recently I was reading one World Economic Forum report, job reports. It talks about what is the future of the customer or future of the student and the faculties, and what kind of job is going to take place by 2030. So this is very enlightening and a very insightful report. If you get chance, you can read it because it's reports, not only limited to India, but is across globe what is happening. It is magnifying. So let me share a few things which is very relevant for all the practitioners and faculties and students. This report forecasts a net increase of 78 million jobs by 2030, with 170 million new roles emerging and 92 million positions being displaced. Why it is happening? This is because of technology is changing very fast. So when we say advancement mainly focus on AI, robotics, and renewable energy reshaping the job landscape and leading to increased demand for specialists of this field. Because the way we are changing the landscape of advancement technology, most of the corporates, they are not able to cope up with the change as fast as required. Because we have a lot of gap in skill and knowledge about all this advanced technology. Because we have been facing in the Godrej, I'm talking about, we have implemented IoT, we have implemented AI, we have implemented robotics, everything we have implemented, and we have hired technology from the Italy. But it is very unfortunate to share this. We have brought technology with high capacity machines and high value, but we are not able to run this machine because of the skill is not there. So that is the very important because unless we develop skill and knowledge of all this technology, we won't be able to sustain because we are aiming for 2047 economy. We will be in the best among 3 best economy in the world. So how we are going to take this initiative forward? So that is very important, and I think the topics which covered by the expert and this design of this that is very, very important because that will help to create a job and in the future. Because I think whatever we are talking today, after 5 years or 10 years, it won't be exist. That is my prediction. Because we have to change our mindset. We have to change as per the requirement of the market, as per the requirement of the customer. How we can do that? We can go for automation. We can go for upskilling and reskilling of the people. We can also reform in the education because aligning education curricula with the evolving demands of the labor market, particularly in the areas of like AI, big data, and cyber security, that will better prepare the workforce for the future challenges. So, and at the same time, the policy intervention is also very important. The government policy should support sectors, poised for growth, encourage investment in technology, and promote sustainable practices to drive job creation. Because unless we do this, we cannot think of 2047. So ultimately, whatever these practitioners or these professors have shared their knowledge, and that will lead to the revolutionizing manufacturing by integrating digital technology, making production smarter and more efficient and adaptable. That is what I see. I could guess within 5-10 minutes. This will help organization to improve the productivity, reduce the cost, and improve the quality. Ultimately, if these things happen in any organization, this organization will survive for a future. So with this, I wish you all the best for all the participants because unless you know the change, you cannot do the change. So I hope whatever insightful information you have got it, and whatever knowledge you have got it, and so you will assimilate all your learnings with the student because they are the future of India, and they are going to take the lead for implementing all this technology for making India among the 3 best economies in the world. So with this, I will conclude my word, and I am also once again I am thankful to Mr. Tyagi, Mr. Ghosh, and Mr. Narvaria, Manoj Narvaria ji, for inviting me and sharing my thought. Thank you very much and wish you all the best.
Thank you so much, sir, for your inspirational words and giving the time from your very busy schedule. Thank you so much, sir.
Thank you, ma'am. Thank you.
At the last, I would like to invite the coordinator of this 1-week faculty development program on recent advances in applications of manufacturing in Industries 4.0, Dr. Manoj Narvaria, coordinator, to propose vote of thanks.
Respected dignitaries, distinguished guests, esteemed speakers, delegates, and participants, a very good evening to all of you. It is my privilege and honor to deliver the vote of thanks on behalf of the organizing committee for this remarkable faculty development program on recent advances applications of manufacturing in Industry 4.0. First and foremost, I express my sincere gratitude to our esteemed resource person and speakers for sharing their valuable insights, expertise, and thought-provoking discussions on the latest advancement in Industry 4.0. Your contributions have undoubtedly enriched our understanding of modern manufacturing technologies and their real-world applications. Your innovative ideas have been the cornerstone of this FDP. First and foremost, I extend my heartfelt thanks to our esteemed Chief Guest, Mr. Avinash Mishra, President of Quality Circle, Forum of India and ex-Vice President, Godrej Consumer Product Limited, for gracing this occasion with your presence, and for your inspirational address. Your insight have truly enriched this event. I am deeply grateful to all our distinguished keynote speakers who have shared their valuable expertise and research. To all the participants and delegates who joined us from across the globe, thank you for your enthusiastic participation, insightful questions, and valuable contributions. It is your active involvement that has made this FDP vibrant and successful. A special thanks to organizing committee whose meticulously planning and tireless effort ensured the seamless execution of this event. To our volunteer, your dedication and hard work behind the scene were instrumental.
Sir, please unmute. Manoj, sir.
Sorry, I was muted. Now, we extend our gratitude to our sponsored ICT ATAL Academy for their generous support and trust in this FDP. Your collaboration has been invaluable in bringing this vision to life. I express my gratitude to IPS administration, Dr. Arun Kumar Tyagi, Director, Mr. Aswini Misra, Working President, Mr. P.K. Ghosh, CEO, IPS Group of Colleges for providing us with all possible logistic support towards organizing this program. Last but not least, I express my gratitude to Dr. Anuragar, Principal, and Dr. Jyoti Misra, Dean Academic, IPS CTM, for providing us with the platform and resources to host this prestigious event. With this, we formally conclude this FDP, hoping that the knowledge gained will inspire further research, innovation, and collaboration in the field of Industry 4.0 and advanced manufacturing. Wishing you all continuous success in your professional endeavor. Thank you all once again for making this FDP a memorable experience. Let us stay connected and we look forward to welcoming you to our next event. Thank you.
Thank you, sir. So, dear participants, I repeat some important instructions for you at the last. The quiz will be displayed on your login on ATAL portal at 8 to 9 p.m. It is requested to all, please solve and submit the quiz. The minimum qualifying score of this quiz is 70%. The feedback link is also provided on your login on ATAL portal. Please fill and submit it within given time. Both the link will be disabled after given time. So it is requested to all please submit both the quiz and feedback within an hour up to 8 to 9 p.m. It is mandatory to all. The certificate of this faculty development program will be based on your attendance and score obtained in quiz on today. After submitting both, your certificate will be uploaded on your ATAL login. You can download from there. The instruction in the form of flowchart has given in WhatsApp group. And the feedback link of this program has also been given in chat box. So please fill and submit it right now. So now we are ending this program with the aim to reconnect again with all of you. Thank you so much, all participants and all the members of organizing committee and guests.
At the end, I want to say something. Please, participate are requested to on your camera. We have to take a snapshot. Please, on your camera, all the participants. Mr. Sushil, please take a snapshot.
Thank you, sir. Thank you very much.
Mr. Sushil, if you completed, then tell us.
Wait 5 minutes.
Please stay only for few minutes.
Feedback link has given in chat box only. Please fill and submit it within 15 minutes.
Okay, done, sir.
No, sir, I think it is done.
Yeah, it is done.
Okay, then. The feedback link has shared in chat box. Please fill and submit it within 15 minutes. And the next feedback link and quiz will be shared on ATAL login. On your ATAL login, please fill and submit between 8 to 9 p.m. Thanks to all participants. Thank you and good night.
Thank you, ma'am. Thank you, sir.
Good night, ma'am. Good night.
Thank you. Thank you.
Thank you, madam.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you so much.
Thank you,
Well
ma'am.
organized.
Thank you, sir.
Thank you,
Thank
ma'am.
you, ma'am.
Thank you, ma'am.
Thank you, madam.
Thank you, ma'am. Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you.
Thank you.
Thank you, ma'am.
Thank you very much, ma'am.
அம்மா அன்னைக்கு மாதிரி பெயிண்ட் விளையாட்டா